Okay, so hello everyone. Welcome to all in your media education. My name is Manish Singh, and today we see the first uh, just a full mock test for HPCL एग्जाम. करेक्ट. तो आप लोग HPCL एग्जाम में टुमारो कंडक्ट होने वाला है, उसमें अपेयर होने वाले हैं. उसके लिए हमने यहाँ पे फुल लेंथ टेस्ट रखा है और यहाँ पे 85 क्वेश्चन मोस्ट रिलेवेंट क्वेश्चंस हमने यहाँ पे पुट किए हैं. तो हो सकता है यहाँ से कुछ क्वेश्चन आपको डायरेक्टली देखने को मिले और ये सेशन आपके लिए बहुत ही इंपॉर्टेंट होने वाला है. करेक्ट. तो अगर हो सकता है कुछ पॉइंट्स अगर आपके रह गए हो, आपने उनका रिवीजन नहीं किया हो, तो यहाँ से आपका वो रिवीजन हो जाएगा. ओके, सो फटाफट ज्वाइन करो सो दैट वी कैन गो फॉर लाइव. एंड एवरीवन ट्राई टू गिव योर आंसर थ्रू चैट बॉक्स. करेक्ट. सो लेट्स स्टार्ट. You can see the first question in your screen. You just see and tell me the correct answer. The first question is strain is defined as the ratio of. The strain is defined as the ratio of. Tell me which one is the right answer. And one more information. Today I will also share one mock test for your homework. Correct. यहाँ पे तो इस पेपर को हम लोग यहाँ पे डिस्कस करेंगे. नेक्स्ट जो पेपर होगा वो आपके लिए होमवर्क में शेयर करूंगा आफ्टर दिस सेशन. तो उसको भी आप सॉल्व कर लेना. तो अप्रोक्सीमेटली 85 प्लस 85 170 क्वेश्चन की आपकी प्रिपरेशन हो जाएगी, रिवीजन हो जाएगा एंटायर फुल लेंथ सिलेबस का. ठीक है. सो द यू कैन सी द करेक्ट आंसर. यस, tell me which one is the right answer. Strain is defined as the ratio of change in volume to the original volume. This is absolutely wrong. And change in length to the original length. Change strain. Yes, strain. Here I am talking about strain. I'm not talking about longitudinal strain or lateral strain or a volumetric strain. So change in volume of original volume, this is called volumetric strain, that is delta V by V naught. And change in length, this is longitudinal strain, that is delta L by L naught. And change in cross sectional area to original cross section area. So simply you can see it can also be written as transverse strain. Correct. Transverse, or you can say lateral strain, which is this. You can see here A naught minus, sorry, delta area means it can be written as, AF minus A naught by A naught. Yes or no? This is change in cross sectional area to the original cross sectional area. Is that right? So the correct answer is option D. Yes, option D is the right one. Strain can be represented in any form. Yes or no? Strain can be represented in any form. That's why the correct answer is option D. यहाँ पे आपसे ये नहीं पूछा कि find tell me the longitudinal strain or a lateral strain or a volumetric strain. These are the strains. Is that right? Okay, let's see another question. Sorry. Okay, so this is the another question. During a tensile test on a specimen of 1 centimeter square cross section, maximum load observed was 80 kilonewton and area of cross section at neck was 0.5 centimeter square. Then what is UTS of the specimen? What is the UTS of the specimen? Tell me. UTS means ultimate tensile strength. Ultimate tensile strength. And UTS, at UTS the area you can see here, it is given here, that is 0.5 centimeter square. So as you know that engineering strain can be represented by load, instantaneous load over original area. Don't forget to write this expression. Pi by A naught. Yes or no? Pi by A naught. So here at the UTS point means at a maximum stress point, the load is 80 kilonewton, 80 into 10 to the power 3 Newton. And what about area? The original area is 1 centimeter square. And if you convert this 1 centimeter into meter, so it can be written as 1 into, and you can see, sorry, you need to convert this centimeter into millimeter, so you just multiply with 100. Yes or no? Multiply with 100. So if you simplify this, then you will get 800 megapascal. 800 megapascal. So don't be confused with this area. Don't be confused with this area. Yes or no? So the correct choice will be option B. The correct choice is option B. Yes or no? Yes, yes. Most of the students given option B. Suman Mandal, you make mistake. तो यहाँ पे ध्यान दो, इंजीनियरिंग स्ट्रेन हमेशा लोड अपॉन ओरिजिनल एरिया होता है. अगर आप यहाँ पे ट्रू स्ट्रेन लिखोगे, अगर आप यहाँ पे ट्रू स्ट्रेन लिखोगे, ट्रू स्ट्रेन के केस में, ट्रू स्ट्रेन के केस में आप यहाँ पे लिख सकते हो इंस्टेंटेनियस लोड अपॉन इंस्टेंटेनियस एरिया. और अगर यहीं पे इनकी वैल्यूज अगर आप पुट करते हो तो आपको यहाँ पे क्या मिलेगा, 0.5 सेंटीमीटर स्क्वायर मीन्स 0.5 इंटू 100. तो ये आपको दोस्तों क्या मिलेगा, 8 this 0, this one is cancelled out with this. So 80,000 divided by 5, 80,000 divided by 5 megapascal. This is true strain. This is true strain. But in this question, we need to find out stress at UTS, and it is not mentioned here to determine true stress or engineering stress. जब तक कुछ भी mention हो, then we always calculate engineering stress. Yes or no? Sorry, engineering stress. Is it right? Okay, so what about this question? Another question again from strength of model. You can see here. Here I am putting all the question in a sequential manner. Correct? Initially, first here I am putting strength of model question. After that, design, then mechanics, like this. Yes or no? So tell me, the Young's modulus at the Poisson's ratio for the certain the Young's modulus and the Poisson's ratio for a certain material are stated to be 1000 GP and 0.25 respectively. The bulk modulus of the material will be, tell me, bulk modulus of the material will be, tell me which one is the right answer. Anyone? फटाफट आंसर करो, फटाफट आंसर करो. You have only 1 minute time to solve this question in your final exam. So you just try to solve this question within 1 minute. Is it right? So the Young's modulus and the Poisson's ratio, you can see here in this question, Young's modulus is given here, that is 1000 GPa, 1000 GPa, and the Poisson's ratio is also given here, that is 0.25. The bulk modulus of the material, so you need to find out bulk modulus, that is K. So as you know, we have one relation for this, E is equal to 3K 1 minus 2 mu, E is equal to 3K 1 minus 2 mu. और यहाँ पे E क्या है, this is 1000 into 3 into 3 into K 1 minus 2 times of 0.25. So this is 0.5. So the K can be written as 1000 divided by 3 into 0.5. And after solving this, how much you get? Tell me. After solving, how much you get? Tell me. 66.67 GPA. 66.67 GPA. 66.67 GPA. Correct? After solving this, you will get 66.67 GPA. I think here we have one mistake. This is 66.67 GPA, not 666. Is it right? 66.67 GPA. This is typing error. So forget it. So the correct answer is option C. The correct answer is option C. Yes or no? Okay, let's see another question. A bar having a cross-sectional area of 700 millimeter square is subjected to axial load at the point at the position. The value of stress in the segment QR. You can see this is PQRS. So you need to find out stress in QR position. Stress in QR position. Correct? So previous one 66. I don't know. This is 66 is right. You just calculate this. Oh, 1000 divided by 1.5. 1000 divided by 1.5. I'm not calculating. Is it 66.67 or 666? 666. Tell me, 666 is the right answer, yes or no? Tell me. If it is right, then this is right, no issue. Okay, so you just try, you just remember this formula. This is very important, and most of the question in these kind of exams they ask from elastic properties, relation and simple bars analysis, yes or no. And few question you also see from uh, combined stresses chapter, yes or no. So let's see one by one. So tell me, what is the right answer for this question? The value of the stress in the segment QR is, the value of stress in the segment QR is, tell me. So you need to draw its free body diagram. You need to find out net load acting on the QR section. So if you draw its free body diagram, so you just cut the section somewhere here. You need not to draw free body diagram for every section. Why? Because we need to calculate only stress in between QR section, yes or no. So you just cut the section like this, and when we cut the section and you just sit here and see towards the right, then here we get, you can see here 45 kilonewton towards the right. So if it is taken as positive value, then you can see this is negative value. So the net force acting on it is nothing but this is 28 kilonewton, yes or no. 28 kilonewton. Here I am taking one sign, that is towards the right force will be taken as positive and towards the left it will be taken as negative. So since this value is positive, this difference is positive, therefore the direction of this net force is towards the right. And if it is acting like this, then reaction will also acting like this, yes or no. And the net value is 28 kilonewton. And now you have area, you have force, then you can easily find out the stress, yes or no. So are you getting how to draw free body diagram for any section? Tell me. If you have any doubt, then you just tell me. If you have any doubt, then you just tell me. Summation of this force is not zero. Okay, you just leave it. So tell me which one is the right answer. So stress is nothing but 28 kilonewton, 28 into 10 to power 3 divided by 700. So sigma is equal to 40 megapascal. Sigma is equal to 40 megapascal. You just follow this rules. You just follow this rules. Yes or no? एंड रेस्ट जो भी है उसको छोड़ दो. ये आपसे खेलना चाहता है, ठीक है. जब क्वेश्चन आपसे खेलना चाहे तो आपको इतना दिमाग ध्यान नहीं देना है, आपको आंसर निकालना है. यू जस्ट ड्रॉ द फ्री बॉडी डायग्राम. कई बार ये जानबूझ के चीजें एरर की जाती है जिससे आप वहां पे कंफ्यूज हो और आप वहीं पे स्टक हो जाते हो. करेक्ट है. आपको सिंपली क्या करना है, सारा कुछ फोर्स दिया है, यहाँ पे हमें रिएक्शन निकालना नहीं, इसलिए हमने यहाँ पे दिमाग नहीं लगाया कि इसमें नेट फोर्स बैलेंस है या नहीं, इक्विलिब्रियम कंडीशन है या नहीं. यू जस्ट कट द सेक्शन, यू फाइंड आउट द नेट फोर्स. जो भी इस सेक्शन में नेट फोर्स एक्ट हो रहा है उसके अकॉर्डिंग यहाँ पे स्ट्रेस इंड्यूस हो जाएगी. इज इट राइट? ओके, नेक्स्ट यू कैन सी अनदर क्वेश्चन. फॉर अ कैंटिलीवर बीम del m by del x is equal to constant, del m by del x is equal to constant for its whole length, what is the shape of shear force diagram for the beam is? Tell me. फटाफट इसका आंसर दो, फटाफट आंसर दो इसको. दिस इज वेरी सिंपल क्वेश्चन. फॉर अ कैंटिलीवर बीम del m by del x is equal to constant, del m by del x is equal to constant. Is it right? Option A, a rectangle. Option B, a triangle. Anyone else? फटाफट आंसर दो दोस्तों, जल्दी से आंसर करो. देखो इस क्वेश्चन की अगर मैं बात करूं तो यहाँ पे बीम कौन सी है? अ कैंटिलीवर बीम. एक कैंटिलीवर बीम है. दिस इज अ कैंटिलीवर बीम. इज इट राइट? हियर वी हैव अ कैंटिलीवर बीम. और क्या बोल रहा है कि del m by del x is equal to constant है. del m by del x is equal to constant है. इज इट राइट? del m by del x यहाँ पे क्या है? कांस्टेंट है. और del m by del x अगर आपका कांस्टेंट है तो आपका शियर फोर्स क्या होना चाहिए? ऑप्शन ए. मोस्ट ऑफ द क्वेश्चंस जो आंसर दे रहे हैं ऑप्शन ए. यस, रेक्टेंगल इज द राइट आंसर. रेक्टेंगल इज द राइट आंसर. करेक्ट. del m by del x इज इक्वल टू कांस्टेंट मींस ये क्या है? del m by del x होता है क्या है? दिस इज शियर फोर्स. del m by del x इज इक्वल टू क्या होता है? दिस इज शियर फोर्स. और अगर बोल रहा है कि ये कांस्टेंट है, अगर ये बोल रहा है कि ये कांस्टेंट है, अगर ये कांस्टेंट है मतलब शियर फोर्स डायग्राम आपका क्या बनेगा, यहाँ पे रेक्टेंगल बनेगा। यस सर नो, इज इट राइट? समझ में आया कि नहीं? डेल एम बाई डेल एक्स अगर कांस्टेंट है और डेल एम बाई डेल एक्स होता है क्या, शियर फोर्स, और शियर फोर्स यहाँ पे कांस्टेंट है मतलब यहाँ पे आपका शियर फोर्स डायग्राम कैसे बनेगा, रेक्टेंगल बनेगा। सो द करेक्ट आंसर इज ऑप्शन ए। Okay, next question you can see the state of plane stress at a point is given as sigma x is equal to 200 megapascal, sigma y is 100 megapascal and tau xy is 100 megapascal. The maximum shear stress is then, tell me मैक्सिमम शियर स्ट्रेस क्या होना चाहिए, बोलो फटाफट आंसर क्या होना चाहिए, टेल मी। दिस इज अ वेरी सिंपल क्वेश्चन, फॉर्मूला बेस्ड क्वेश्चन है। फॉर्मूला में वैल्यू पुट करो देन यू विल गेट द आंसर। फॉर्मूला पुट करो, वैल्यू पुट करो, डायरेक्ट आपको आंसर मिलेगा यहाँ पे। टेल मी, फटाफट आंसर करो बंधु, इतना टाइम लोगे कैसे काम चलेगा? विद इन 30 सेकेंड आपको क्वेश्चन सॉल्व करना है। आपसे पूछा जा रहा है व्हाट इज मैक्सिमम शियर स्ट्रेस, टाउ मैक्स का फॉर्मूला है, डायरेक्ट अप्लाई करो, स्क्वायर रूट ऑफ सिग्मा एक्स माइनस सिग्मा वाई बाई 2 होल स्क्वायर प्लस टाउ एक्स वाई स्क्वायर। इस फॉर्मूला में वैल्यू पुट करना है, आपको आंसर मिल जाएगा। स्क्वायर रूट ऑफ सिग्मा एक्स की वैल्यू क्या है, 200 मेगा पास्कल, सिग्मा वाई की वैल्यू क्या है, 100 मेगा पास्कल, डिवाइडेड बाई 2 होल स्क्वायर प्लस 100 स्क्वायर। ये आर नो? अगर आप इसको सिंप्लीफाई सॉल्व करोगे तो 200 माइनस 100 इसका डिफरेंस क्या आएगा, 100 बाई 2 50 स्क्वायर, स्क्वायर रूट ऑफ 50 का स्क्वायर प्लस 100 का स्क्वायर। ये आर नो? इज इट राइट? 50 स्क्वायर प्लस 100 स्क्वायर, 50 स्क्वायर प्लस 100 स्क्वायर। ये आर नो? तो ऑब्वियसली ये 100 से ज्यादा होगा, करेक्ट, लेकिन 150 से कम होगा। 100 से ज्यादा होगा और 150 से कम होगा। यस आर नो? तो यहाँ पे सिर्फ एक ही ऑप्शन मिल रहा है, वो है 111.8, करेक्ट। तो कई बार आपको ऐसे अप्रोक्सीमेशन लेना है, बहुत ज्यादा कैलकुलेशन नहीं करनी है। इज इट राइट? चलिए आगे बढ़ते हैं। नेक्स्ट, which of the following is not exactly a property of material? Tell me, which of the following is not exactly a property of the material? चलो बोलो फटाफट, फटाफट बोलो क्या आंसर होना चाहिए। और इसका देखो, इसका कंप्लीट डिटेल आंसर शीट मैं आपको शेयर करूंगा टेलीग्राम में, करेक्ट है? तो इस वीडियो के डिस्क्रिप्शन में टेलीग्राम लिंक होगी, उसको आप ज्वाइन कर सकते हो। आपको इस पेपर का डिटेल सोल्यूशन और जो अपकमिंग पेपर है, जो नेक्स्ट टेस्ट पेपर है, सेकंड टेस्ट पेपर, हमने 2 मॉक टेस्ट रखे थे। फर्स्ट हम यहाँ पे लाइव जा रहे हैं, दूसरा हम आपको आपके घर में आपको सॉल्व करने के लिए देंगे, करेक्ट है? दोनों आप सॉल्व करो, उनका सोल्यूशन भी है, तो आपको वहां पर टेंशन की बात नहीं है, सॉल्व करो और बाद में आप आंसर उनको मिला सकते हो, उनका सोल्यूशन देख सकते हो, करेक्ट है? तो पूछ रहा है विच ऑफ द फॉलोइंग इज नॉट एग्जैक्टली प्रॉपर्टी ऑफ मटेरियल। तो पूछ रहा है एंड्योरेंस लिमिट, अल्टीमेट टेंसाइल स्ट्रेंथ, इलास्टिक मॉडुलस, यील्ड स्ट्रेंथ। देखो, यील्ड स्ट्रेंथ इज द प्रॉपर्टी ऑफ द मटेरियल, इलास्टिक मॉडुलस इज द प्रॉपर्टी ऑफ द मटेरियल। यस आर नो? इज इट राइट? तो ये आंसर नहीं होंगे। एंड्योरेंस लिमिट की अगर मैं बात करूं तो एंड्योरेंस लिमिट इज आल्सो प्रॉपर्टी ऑफ द मटेरियल, तो ये भी आंसर नहीं हुआ। तो करेक्ट आंसर अल्टीमेट टेंसाइल स्ट्रेंथ, अल्टीमेट टेंसाइल स्ट्रेंथ। इज इट राइट? ऑल्दो एंड्योरेंस लिमिट जो होता है वो सरफेस कैरेक्टरिस्टिक्स पे भी डिपेंड करता है। ऑल्दो अल्टीमेट सॉरी एंड्योरेंस लिमिट जो है ये सरफेस कैरेक्टरिस्टिक्स पे भी डिपेंड करता है, करेक्ट है? बट हम इसको प्रॉपर्टी कह सकते हैं फॉर अ गिवन मटेरियल, ये प्रॉपर्टी होती है। इज इट राइट? विच ऑफ द फॉलोइंग की हैव सेल्फ अलाइनिंग प्रॉपर्टी? इन सभी कीज में कौन सी की है जो सेल्फ अलाइनिंग प्रॉपर्टी रखती है? टेल मी। यील्ड स्ट्रेस मस्ट बी आंसर ना, यील्ड, यहाँ पे क्वेश्चन पूछा क्या है, नॉट एग्जैक्टली अ प्रॉपर्टी। आप एग्जैक्ट प्रॉपर्टी की बात कर रहे हो, अगर आप एग्जैक्ट प्रॉपर्टी बोलोगे तो होगा आंसर। प्रॉपर्टी कौन सी नहीं है ये क्वेश्चन पूछा गया। इज इट राइट? ओके, सो टेल मी विच वन इज द राइट आंसर। सेल्फ अलाइन प्रॉपर्टी कौन सी कीज में होती है? यस, वुडरफ की इज द राइट आंसर, वुडरफ की इज द राइट आंसर, वुडरफ की इज द राइट आंसर। इज इट राइट? वुडरफ की इज द राइट आंसर। ओके, नेक्स्ट क्वेश्चन, M12 इंटू 1.25 रेस्पेक्टिवली रिप्रेजेंट्स, यहाँ पे क्या बताता है ये, एम M12 इंटू 1.25 रिप्रेजेंट्स, ये क्या है ये, दिस इज द डेजिग्नेशन ऑफ, this is the designation of screw thread, yes or no, screw thread, tell me which one is the right answer, tell me the right answer. देखो M12 यहाँ पे जो लिखा है इसका मीनिंग पहले आप समझो कि M12 है क्या, M12 इंटू 1.25, देखो M का मतलब होता है मीट्रिक थ्रेड, M का मतलब होता है मीट्रिक थ्रेड, इज इट राइट, M का मतलब होता है मीट्रिक थ्रेड, 12 जो बता रहा है यहाँ पे नॉमिनल डायमीटर, नॉमिनल डायामीटर, इज इट राइट, और 1.2 जो यहाँ पे बता रहा है दोस्तों ये पिच को बताता है, पिच को बताता है, और जब भी फाइन पिच होती है, जब भी फाइन पिच होती है तो हम इसको इस तरीके से रिप्रेजेंट करते हैं, करेक्ट है, जब भी फाइन पिच होगा, अगर यहाँ पे कोर्स पिच होगा तो डायरेक्टली इसको M12 से रिप्रेजेंट किया जाता है, पिच को नहीं बताया जाता, तो जब भी फाइन पिच होती है तो इसको हम बताते हैं, पिच भी बताते हैं इस डेजिग्नेशन में, इज इट राइट, करेक्ट, तो ये याद रखना, ऑप्शन ए इज द राइट आंसर. Okay, next question. A 60 mm long and 6 mm thick fillet weld carries a steady load of 20 kilonewton along the weld. The shear strength of the weld material is equal to 200 megapascal. The margin of safety is. बताओ इसका क्या आंसर होना चाहिए? Tell me which one is the right answer. बोलो which one is the right answer? Anyone? फटाफट बता दो क्या आंसर है. A 60 mm long and 6 mm thick. देखो जो फिलेट वेल्ड है उसकी लेंथ यहाँ पे गिवन है, फिलेट वेल्ड की जो लेंथ है वो गिवन है, और वो लेंथ है आपकी 60 मिलीमीटर, इज इट राइट, और थिकनेस टी दिया हुआ है 6 मिलीमीटर, तो अगर आपको पता हो थ्रोट हाइट अगर हम देखें तो ये 0.707 टाइम्स ऑफ टी होता है, तो यहाँ से आप थ्रोट की हाइट निकाल सकते हो 0.707 इंटू 6 मिलीमीटर, इज इट राइट. फिर क्या पूछ रहा है, द फिलेट वेल्ड carries a steady load of 20 किलोमीटर along the weld. The shear strength of the weld material is 200 megapascal. देखो shear strength आपको यहाँ पे पता है, shear strength क्या होगा, फोर्स, मैक्सिमम shear load, दैट मैक्सिमम shear stress की वजह से, इस मैक्सिमम स्ट्रेंथ की वजह से इसकी मैक्सिमम लोड कैरिंग कैपेसिटी जो होगी वो PS होगी डिवाइडेड बाय shear एरिया, तो shear एरिया क्या लिख सकते हैं दोस्तों हम, 0.707 इंटू टी इंटू एल, यस आर नो, and this is nothing but this is called as throat height, this is called as throat height, तो यहाँ से PS क्या मिल जाएगा 0.707 इंटू टी इंटू एल इंटू टाउ, यस आर नो. अब यहाँ पे इसकी वैल्यू पुट करो तो आपको क्या वैल्यू मिलेगी दोस्तों, 0.707 इंटू 6 इंटू लेग लेंथ इज गिवन 60 एंड शियर स्ट्रेंथ इज आल्सो गिवन 200 मेगापास्कल. सो यहाँ से आपको टोटल फोर्स पता चल जाएगा, और चूंकि किलो न्यूटन में तो इसको भी मैं किलो न्यूटन में कन्वर्ट करने के लिए 1000 से डिवाइड कर दूं तो ये आपको मिल जाएगा किलो न्यूटन. तो ये क्या बताता है, दिस इज द मैक्सिमम लोड कैरिंग कैपेसिटी ऑफ दिस फिलेट वेल्ड. तो आपसे पूछ रहा है कि मार्जिन ऑफ सेफ्टी क्या होगा, तो मार्जिन ऑफ सेफ्टी की या फैक्टर ऑफ सेफ्टी की अगर मैं बात करूं तो टोटल लोड कैरिंग कैपेसिटी, टोटल लोड कैरिंग कैपेसिटी डिवाइडेड बाय, यहां पे मैं लिख देता हूं टोटल लोड कैरिंग कैपेसिटी, टोटल लोड कैरिंग कैपेसिटी डिवाइडेड बाय यहाँ पे क्या लोड हम अप्लाई करें, स्टडी लोड क्या अप्लाई करें, अप्लाइड लोड. तो यहां से आपको पता चल जाएगा कि मार्जिन ऑफ सेफ्टी यहाँ पे क्या है, इज इट राइट, यहां से आपको पता चल जाएगा मार्जिन ऑफ सेफ्टी क्या है, इज इट राइट. तो आफ्टर कैलकुलेशन आप चेक कर लेना, मैं यहाँ पे कैलकुलेशन नहीं करने जा रहा हूं, तो यहाँ पे इसकी वैल्यू आती है 904 kilonewton divided by 20, or after solving this we will get, तो ये सॉरी ये फैक्टर ऑफ सेफ्टी है, दिस इज नॉट मार्जिन ऑफ सेफ्टी, दिस इज फैक्टर ऑफ सेफ्टी, दिस इज फैक्टर ऑफ सेफ्टी, एंड यहां से फैक्टर ऑफ सेफ्टी की वैल्यू आती है दोस्तों 2.54, 2.54, and after getting this margin of safety, sorry, after getting this factor of safety, जो मार्जिन ऑफ सेफ्टी होगा यहाँ पे, तो सिंपली यहाँ पे लिख सकता हूँ मार्जिन ऑफ सेफ्टी इज नथिंग बट दिस इज फैक्टर ऑफ सेफ्टी -1, इज इट राइट, फैक्टर ऑफ सेफ्टी -1, और यहां से जब आप इसको सॉल्व करोगे तो ये आंसर मिलेगा 2.54 -1, that is 1.54, 1.54 is the right answer, so option C is the right one, option C is the right one, yes money, option C is the right one. देखो कैलकुलेटर नहीं कर रहेगा, लेकिन आपको कई बार ऐसे कैलकुलेशन देखने को मिलेंगे और आपको करना पड़ेगा, तो अप्रोक्सीमेशन लेके आप इनको सॉल्व कर सकते हो, इज इट राइट, अप्रोक्सीमेशन लेके आप इनको सॉल्व कर सकते हो, करेक्ट। इसलिए मैंने यहाँ पे कुछ क्वेश्चन रखे हैं, कई बार हमें कुछ कैलकुलेशन करनी पड़ती है, तो आपको यहाँ पे करना क्या है कि जब भी आप इस तरीके के कैलकुलेटिव क्वेश्चंस देखें तो पहले तो फर्स्ट स्टेप में उसको स्किप करना है। अगर दोस्तों मैं यहाँ पे स्टेप बताऊं कि आपको पेपर कैसे अपेयर होना है, सो व्हेनेवर यू अपेयर इन द एग्जाम, ऑब्वियसली दिस इज सीबीटी एग्जाम, ऐसा कंप्यूटर बेस्ड टेस्ट, सो फर्स्ट आपको क्या करना है कि उन क्वेश्चन को सॉल्व करना है जो आपको 100% पता है, उनको क्वेश्चन देखते जाओ, फटाफट टिक करते चले जाओ, यस और नो। जिस क्वेश्चन में आपको कैलकुलेशन थोड़ा सा लगे कि लेंथी है, उसको आप वहां पे छोड़ दो, उसको मेंशन कर दो, इसको बाद में चेक करना है, करेक्ट है, मेंशन जरूर कर देना, नहीं तो आप क्वेश्चन बाद में ढूंढ ही नहीं पाओ, कुछ क्वेश्चन को सॉल्व करना है तो मेंशन कर देना, और मेंशन इस तरीके से करना कि आपको पता है कि इस क्वेश्चन को आप सॉल्व कर सकते हो, लेकिन थोड़ा सा लेंथी है जिसे मैं बाद में करूंगा। उसके बाद आपको क्या करना है, उसके बाद आप क्या करोगे, एक बार पूरा पूरा पेपर सॉल्व करके आगे बढ़ जाओ, जब आपके पास टाइम बचे तो फिर इन क्वेश्चंस को यहाँ पे ट्राई करोगे, इज इट राइट। फर्स्ट टाइम आपको ऐसे क्वेश्चन ट्राई नहीं करने हैं जो लेंथी कैलकुलेशन हो, जैसे मैं इसकी बात करूं यहाँ पे कैलकुलेशन काफी ज्यादा है, इसको आपको बाद के लिए छोड़ देना है, अगर टाइम बचे तो करना, अदरवाइज इसको छोड़ देना है, इज इट राइट, करेक्ट। तो इसीलिए अब इस तरीके से आपको स्ट्रेटेजी फॉलो करना है। ओके, नेक्स्ट क्वेश्चन, विच वन ऑफ द फॉलोइंग इज नॉट अ फ्रिक्शन क्लच, टेल मी विच वन इज द राइट आंसर। Yes, yes, option D. Option D is the right answer. Yes, jaw clutch is the right answer. Jaw clutch is the right answer. Is it right? Jaw clutch is the right answer. यहाँ पे क्या होते हैं, इस jaw clutch में ऐसे टूथ बने होते हैं. Is it right? Like this. तो यहाँ पे क्या होता है, ये फ्रिक्शन पे बेस पे नहीं काम करता है, क्लैंपिंग के बेस पे काम करता है. Is it right? क्लैंपिंग के बेस पे ये काम करता है. Next, crystal structure of the material is studied by. Tell me which one is the right answer. Crystal structure of the material is studied by metallographic technique, X-ray technique, electron microscopy, high powered microscopy. Yes, X-ray technique is generally used for crystal structure analysis. X-ray technique is used generally for crystal structure analysis. But if I talk about non-metals, non-metals के लिए आप क्या यूज करोगे, generally X-ray technique is used, X-ray diffraction method, इसको XRD बोलते हैं, करेक्ट है, इसको हम XRD बोलते हैं, एक्सरे डिफ्रैक्शन मेथड, XRD। तो XRD जनरली यूज होता है फॉर मेटालिक क्रिस्टलाइन मटेरियल, एक्सरे डिफ्रैक्शन, यस, एक्सरे डिफ्रैक्शन मेनली यूज फॉर क्रिस्टलाइन मटेरियल। अगर मैं नॉन क्रिस्टलाइन मटेरियल की बात करूं, नॉन क्रिस्टलाइन मींस एमॉर्फस और नॉन मेटल्स, तो न्यूट्रॉन डिफ्रैक्शन इज मेनली यूज्ड, न्यूट्रॉन डिफ्रैक्शन इज मेनली यूज्ड, इज इट राइट। Okay, next, the correct order of coordinate number in simple cubic, body centered, face centered, and hexagonal closed pack unit cell is. Tell me which one is the right answer. Which one is the right answer? The correct order of coordinate number. This is coordinate number. Coordinate number means a atom which is surrounded by how many number of neighbor atoms. So most of the students given option B. Option B. Okay, so simple cubic 6, yes, of BCC 8, this is 12, this is 12, yes, option B is the right answer. Option B is the right answer. Very good, option B is the right answer. Okay, planar density in simple cubic on 100 plane. Tell me which one is the answer. Which one is the correct answer? You can see here, this is simple cubic structure. In each corner we have one atom like this. So if I talk about 100 plane, so can I say this is 100 plane? Yes or no? This is 100 plane. Correct? So tell me which one is the right answer? Option 14B. Option B. A 1 by root 2 a square. Anyone else? Yes, most of the students given option B. So you can see the planar density is nothing but number of atoms, number of atoms, number of atoms in a plane. Simply you can write divided by area of plane. Yes or no? Area of plane. So like this you can find out. So obviously you can see if I talk about this plane, so you can see one corner atom here, one corner atom here, one corner atom here. So this is 1/4 of circle. Yes or no? In each corner we have 1/4 of circle. So अगर इनको आप merge करोगे, then you will get number of effective atoms is 1. Number of effective atoms in is 1 in this plane. And area is, what about area? This is A and A. So simply planar density can be written as 1 by A square. 1 by A square. Yes or no? 1 by A square. Is that right? 1 by A square. And if I talk about A is equal to 2R, yes or no? A is equal to 2R. Is that right? So according to this, if I see, none of the option is right. Correct? And let's see, if I talk about in terms of radius, might be A is radius. सो अगर आप इसको रेडियस के फॉर्म में भी देखें, अभी यहाँ पे इसके अकॉर्डिंग तो कोई आंसर सही नहीं है, सॉरी, ये कुछ इस तरीके से कनेक्टेड होता है, करेक्ट है। तो यहाँ पे हम लिख सकते हैं ए इज इक्वल टू 2 टाइम्स ऑफ आर, ए इज इक्वल टू 2 टाइम्स ऑफ आर, यस आर नो, और ए इज इक्वल टू 2 टाइम्स ऑफ आर। यहाँ पे मैंने एक्चुअली इनको ज्वाइन कर देना चाहिए था, सो दिस इज नॉट राइट फिगर, मैं इसको चेंज कर देता हूँ, ये कुछ ऐसा होगा। सिंपल क्यूबिक में सारे एटम्स एक दूसरे से कनेक्टेड होते हैं, इज इट राइट? करेक्ट। तो यहाँ पे अगर आप हम देख यहाँ पे अगर हम देखें तो एरिया, सॉरी, ए क्या हो जाएगा 2r, और ये एरिया ए इज इक्वल टू 2r। सो अगर आप एरिया निकालोगे तो यही आएगा, और प्लेनर डेंसिटी निकालना है तो नन ऑफ द करेक्ट आंसर। यहाँ पे मैं ऑप्शन ई ऐड कर देता हूँ, 1 by a square, दिस इज द राइट आंसर। 1 by a square is the right answer. Is it right? 1 by a is the right answer. And this is simple cubic. Is it right? This is simple cubic. अगर ये सिंपल क्यूबिक की जगह बॉडी सेंटर्ड क्यूबिक होता है बीसीसी, तब यहाँ पे कुछ स्टोरी बदल जाती है। बीसीसी केस में 100 प्लेन में अगर आप एटम देखते तो उस केस में आपको नंबर ऑफ एटम तो 1 ही मिलता, लेकिन अगर मैं यहाँ पे रिलेशन लिखता तो कुछ और मिलता। ये सर नो, तो माइट बी या तो यहाँ पे सिंपल क्यूबिक की जगह बीसीसी रहा होगा। इज इट राइट? उस केस में आंसर मिल सकता है। अदरवाइज इसके लिए हमारा करेक्ट आंसर क्या होगा? दिस वन, 1 by a square is the right answer. तो ये आपके प्रोसेस होती है, नंबर ऑफ इफेक्टिव एटम्स पता करो डिवाइडेड बाय एरिया ऑफ प्लेन, तो ये आपको मिल जाएगा प्लेनर डेंसिटी। और अगर यहीं पे लीनियर डेंसिटी निकालना होता है तो नंबर ऑफ एटम्स इन वन लाइन डिवाइडेड बाय लेंथ ऑफ दैट लाइन, यस और नो। इस तरीके से हम लीनियर डेंसिटी भी निकाल सकते थे, करेक्ट। तो अभी इस पर्टिकुलर प्रॉब्लम में 1 by a square is the right answer, correct? Okay, so what about this? Brittle fracture is more dangerous than ductile fracture. Why? Brittle fracture is more dangerous than the ductile fracture. Why? Because, tell me which one is the right answer. No warning sign, crack propagates at a very high speed, no need for extra stress during crack propagation, all of this. Tell me which one is the right answer. Yes, correct. Yes, option D is the right one. Option D is the right one. Brittle material doesn't given a proper indication of failure. Yes or no? That's why this is much severe than ductile fracture. Yes or no? And crack propagation also very high in brittle material. अगर आप सपोज, अगर मैं ब्रिटल मटेरियल ग्लास की बात करता हूँ, उसमें अगर सिंपल से एक स्क्रैच फॉर्म कर दो तो वो स्क्रैच पूरा प्रोपोगेट हो जाएगा। और इसका आपने बहुत बढ़िया से फील किया होगा, और आपके मोबाइल का टफन ग्लास है, उसमें जरा सा भी कहीं भी क्रैक बना तो पूरा का पूरा ग्लास में वो क्रैक फॉर्म हो जाता है। दैट इज कॉल्ड क्रैक प्रोपोगेशन। ब्रिटल मटेरियल में क्रैक प्रोपोगेशन बहुत फास्ट होता है। इज इट राइट? ओके। Guideways of lathe beds are hardened by. Guideways of lathe beds are hardened by. नेगेटिव मार्किंग होगी बालको, नेगेटिव मार्किंग होगी। आई थिंक 1/3 या 1/4 है, 1/4 0.25। Guideways of the lathe beds are hardened by. Flame hardening, yes, flame hardening. Flame hardening is the right answer. Flame hardening is the right answer. Refractory slurry is used in, tell me, refractory slurry is used in cell mold casting, centrifugal casting, investment casting, and die casting. Refractory slurry is used in. Yes, tell me which one is the right answer. Refractory slurry is used in. Tell me fast. Tell me fast. Don't be confused with cell molding and investment casting. This is the investment casting. This is the right answer. This is the right answer. Investments. जब भी रिफ्रैक्टरी स्लरी की बात करेगा तो उसका आंसर होगा इन्वेस्टमेंट कास्टिंग. ऑल्दो इन सेल मोल्डिंग we also use slurry in which we use a sand particle, very sand particle with फिनोलिक रेजिन. वहां पे फिनोलिक रेजिन यूज होता है. और हाँ यस, वहां पे फिनोलिक रेजिन यूज होगा. एल्कोहल यूज होता है अगर आप सेल मोल्डिंग की बात करो. करेक्ट है. फिनोलिक रेजिन, एल्कोहल एंड वहां पे फाइन ड्राई सैंड, सिलिका सैंड यूज होता है. जबकि अगर मैं बात करूं इन्वेस्टमेंट कास्टिंग में तो यहाँ पे आपका क्या यूज होता है? इसमें मेनली वी यूज अ वेरी फाइन सिलिका सैंड with water, yes or no? Very fine silica sand with water with some binders, yes or no? Is that right? Is it right? So यहाँ पे आपको कंफ्यूज नहीं होना. ऑप्शन डी तो कतई नहीं है. डाई कास्टिंग में कभी यूज नहीं करते स्लरी. ठीक है. और सेंट्रीफ्यूगल कास्टिंग में भी कभी स्लरी नहीं यूज होगा. कंफ्यूजन जो था सिर्फ ए और सी में होना चाहिए था. तो करेक्ट आंसर सी है. दैट्स व्हाई इन्वेस्टमेंट कास्टिंग इज मेनली यूज्ड फॉर कास्टिंग ऑफ हाई मेल्टिंग टेम्परेचर एलॉयज. जो जिनका टेम्परेचर बहुत ज्यादा होता है मेटल का, उनको भी हम इजिली कास्ट कर सकते हैं विद हेल्प ऑफ इन्वेस्टमेंट कास्टिंग, जस्ट बिकॉज ऑफ दिस स्लरी refractory slurry, yes or no? Waviness of a machine surface is caused only by, tell me, waviness of a machine surface is only caused by. Tell me which one is the right answer. Waviness of a machine surface is mainly caused by machine tool vibration, 18A, worm out cutting tools geometry, excessive depth of cut, excessive heat generation during machining. Yes, it is right. Excessive tool vibration. Excessive machine tool vibration is the main reason behind this. Okay, misrun is a casting defects which occurs due to. Misrun is a casting defects which occurs due to. Tell me, which one is the right answer? Very high pouring temperature. This is absolutely wrong. Insufficient fluidity of molten metal. Yes, it is right. Absorption of gases by the liquid metal. No. Absorption of the gases by the liquid metal, it produces blowholes type defect, yes or no? Or gas entrapment defects, improper alignment of molds, correct? This is also a defects due to mold flaws, improper alignment. So the correct answer is insufficient fluidity of the molten metal, and mostly it happens in case of ferrous alloys. Why? Because ferrous alloys has low fluidity. ferrous alloys में fluidity कम होती है दोस्तों. तो इसके लिए जनरली हम लोग यूज करते हैं टॉप गेटिंग सिस्टम. इज इट राइट? और इसको हम कैसे कम कर सकते हैं मिश्रण डिफेक्ट्स को? बाय प्रोवाइडिंग एक्स्ट्रा डिग्री ऑफ सुपरहीट. अगर मैं यहाँ पे कूलिंग कर्व बनाऊं, देखो यहाँ पे ध्यान से, अगर यहाँ पे हम कूलिंग कर्व देखें, टेम्परेचर वर्सेस टाइम ग्राफ अगर हम यहाँ पे देखें, दिस इज कूलिंग कर्व. तो आपने देखा होगा कूलिंग कर्व कुछ इस तरीके से होता है. तो यहाँ पे देखो फर्स्ट जो होता है दिस इज कॉल्ड डिग्री ऑफ सुपर हीट, इसको हम बोलते हैं डिग्री ऑफ सुपर हीट। क्यों? क्योंकि मेटल तो ऑलरेडी इस स्टेट में मेल्ट हो चुका है, इसके बाद भी हम इसको क्यों गर्म कर रहे हैं? इसको हम इसीलिए गर्म कर रहे हैं क्योंकि वाइल फ्लोइंग ऑफ मोल्टेन मेटल हर जगह यहाँ पे हीट क्या होगा, हीट लॉस होगा। तो उस हीट लॉस की वजह से कहीं इतना ना लॉस हो जाए कि मेटल पहले एक्सट्रीम एंड में पहुंचने से पहले सॉलिडिफाई हो जाए। इसलिए हम क्या करेंगे, इस डिग्री ऑफ सुपर हीट को बढ़ा के भी हम मिश्रण डिफेक्ट्स को मिनिमाइज कर सकते हैं। और एक बार मैं आपको बता दूं मिश्रण डिफेक्ट होता क्या है। अगर सपोज आपको इस तरह की कास्टिंग प्रोड्यूस करनी है एल शेप की, और आपने यहाँ से मोल्टेन मेटल पोर करने स्टार्ट किया, तो एक्सट्रीम एंड में पहुंचने से पहले ही मेटल सॉलिडिफाई हो जाए, देन दिस इज कॉल्ड एज मिश्रण डिफेक्ट। और एक और डिफेक्ट आया कोल्ड सेट डिफेक्ट, तो समवॉट दोनों सेम होते हैं। कोल्ड सेट डिफेक्ट और मिश्रण डिफेक्ट दोनों का रीजन लगभग एक जैसा ही होता है। देखो यहाँ से आप मोल्टेन मेटल पोर कर रहे हो, इधर से मोल्टेन मेटल पोर कर रहे हो, और दोनों स्ट्रीम अगर प्रॉपर्ली फ्यूज ना हो तो इसे कोल्ड सेट डिफेक्ट कहते हैं। और दोनों का रीजन यही है, इनसफिशिएंट फ्लूइडिटी, इनसफिशिएंट पोरिंग टेम्परेचर, इम्प्रॉपर प्लेसमेंट ऑफ राइजर, ये सार नो ये इसका रीजन है। इसको हम कैसे मिनिमाइज कर सकते हैं? बाय प्रोवाइडिंग प्रॉपर प्लेसमेंट ऑफ राइजर, बाय प्रोवाइडिंग डिग्री ऑफ सफिशिएंट डिग्री ऑफ सुपर हीट, करेक्ट। इस तरीके से हम इसको करेक्ट कर सकते हैं। ओके, नेक्स्ट क्वेश्चन यू कैन सी हियर, which one of the following is used for checking of flatness in the gauge block? गेज ब्लॉक की फ्लैटनेस को चेक करने के लिए हम लोग क्या यूज करते हैं? बोलो। Tell me which one is the right answer. Which one of the following is used for checking of flatness in the gauge block? क्या आंसर सही होगा? ऑप्शन बी, ऑप्शन बी ऑप्टिकल कंपैरेटर। नो, रॉन्ग आंसर, रॉन्ग आंसर। देखो यहाँ पे करेक्ट आंसर होगा ऑप्टिकल फ्लैट। ऑप्टिकल फ्लैट इज मेनली यूज फॉर चेकिंग ऑफ फ्लैटनेस इन द गेज ब्लॉक। इज इट राइट? होता क्या है, इंटरफेरोमेट्री प्रिंसिपल पे ये काम करता है। आपके पास ये एक ऑप्टिकल फ्लैट है जिसके ऊपर आपने अपने क्या लिखा है, हाँ, गेजेस को रख दिया, गेज ब्लॉक को यहाँ पे रख दिया, और यहाँ से ऑप्टिकल फ्लैट, यहाँ से लाइट आएगा, लाइट ट्रांसमिट होकर लौट जाएगा। तो इंटरफेरोमेट्री की प्रिंसिपल की हेल्प से हम पता कर लेते हैं इसमें फ्लैटनेस क्या होती है। यस और नो, इज इट राइट? तो ऑप्टिकल फ्लैट इज द राइट आंसर। Okay, next, keeping the surface area constant if the volume of casting is doubled by changing its design, the solidification time is expected to increase by the factor. Tell me which one is the right answer? Which one is the right answer? 21C. Keeping the surface. Here we need to find out the solidification time. Then obviously you know that solidification time is directly proportional to V by SA whole square, where V is the volume and SA is the surface area. करेक्ट? तो इसको हम सिंपली लिख सकते हैं, दिस इज के टाइम्स V by SA होल स्क्वायर। करेक्ट? अब यहाँ पे देखो क्या कर रहा है, कीपिंग द सरफेस एरिया कांस्टेंट, मतलब सरफेस एरिया हमारा ये कांस्टेंट है। इफ द वॉल्यूम ऑफ द कास्टिंग इज डबल्ड, then changing its design, the solidification time is expected. So you can see here the solidification time is directly proportional to volume square. Yes or no? So TS2 by TS1 is equal to V2 by V1 whole square. और यहाँ पे कह रहा है कि डिजाइन द वॉल्यूम ऑफ द कास्टिंग इज डबल्ड, तो ये सिंपली क्या आ जाएगा, 2 का स्क्वायर दैट इज 4, 2V बाई V दैट इज 2 स्क्वायर, यहाँ पे आ जाएगा 4। सो द करेक्ट आंसर इज 4। जो सॉलिडिफिकेशन टाइम है 4 टाइम्स वो इंक्रीज हो जाएगा। ओके, और क्यों ना इंक्रीज हो, देखो एक बात और बता दूं, जो वॉल्यूम होता है दिस रिप्रेजेंट्स द अमाउंट ऑफ हीट कंटेंट, अमाउंट ऑफ हीट अवेलेबल इन द मटेरियल, एंड सरफेस एरिया रिप्रेजेंट्स हाउ मच हीट इज ट्रांसफर्ड। यस और नो? अगर आप वॉल्यूम हीट कंटेंट को बढ़ाओगे देन ऑब्वियसली इट टेक्स मोर टाइम टू ट्रांसफर द हीट विद सेम एरिया। यस और नो? इज इट राइट? Okay, which one of the following material is best suited for optical flat? Yes, tell me. Another question from optical flat. Yes, very good, very good. Yes, quad is the right answer. Yes, quad is the right answer. Very good. Quad is the right answer. Quad is the right answer. Thread rolling is restricted to. Thread rolling is restricted to. Tell me. Ferrous material, ductile material, hard material, none of these. Which one is the right answer? Ductile material. Thread rolling cannot be performed by ductile material. Why? Tell me. Tell me which one is the right answer. Which one is the right answer? Tell me which one is the right answer. Yielding occurs. Yes. Option B is the right answer. Ductile material cannot be rolled because of elastic recovery of the material. Because of elastic recovery of the material. Is it right? Huge elastic recovery takes place. Interferometry is used to measure. Interferometry is used to measure. Tell me which one is the right answer. Flatness, straightness, roundness. Which one is the right answer? Which one is the right answer? Option B, option B. Most of the students given option B. Yes, option B is the right answer. Flatness is the right answer. Okay, so another question. You can see here I am writing this is 535 minus 0.009 minus 0.025. Now it is visible to you, correct? A shaft has a dimension 535 minus 0.09 to 0.025. The respective values of fundamental deviation and tolerances are. What is fundamental deviation and tolerances? So you can see shaft. Yes, here I am talking about shaft. So let us suppose this is a shaft. This is shaft. Is it right? This is shaft. Is it right? So from this is the reference. So this is called basic size. क्या कहते हैं इसको हम? This is called basic size और जीरो साइज. इसे बोलते हैं जीरो लाइन. इज इट राइट? दिस इज कॉल्ड जीरो लाइन. करेक्ट. तो इस जीरो लाइन से यहाँ पे जो 35 है दिस इज बेसिक साइज. करेक्ट. 35 से अगर आप इसको यहाँ पे इसको सब्सट्रैक्ट कर दो, ये आपको मिल जाएगा क्या? दिस इज अपर लिमिट. तो अपर लिमिट ऑफ द शाफ्ट क्या आएगा? अपर लिमिट ऑफ द शाफ्ट क्या आएगा? देखो 35 माइनस 0.009. Yes or no? And after solving this, here we get 34.991. Yes or no? This is upper limit. And similarly, what about lower limit? What about lower limit? Tell me. This is upper limit. This is upper limit. So now tell me, what is lower limit? Okay, so this is upper limit. So how you calculate lower limit? Tell me. And if I see in this figure, this is lower limit. Is it right? So lower limit is nothing but this is equal to 35 minus 0.025. Yes or no? And after solving this, here I am getting 34.991. 34.975. 975, yes or no? Is it right? So you have upper limit, you have lower limit, करेक्ट? तो सबसे पहले अगर मैं आपको बता दूं फंडामेंटल डेविएशन क्या है, तो फंडामेंटल डेविएशन होता है नियरेस्ट डेविएशन, करेक्ट? तो नियरेस्ट यहाँ पे डेविएशन कौन सा हो रहा है? अपर लिमिट. दिस इज माय फंडामेंटल डेविएशन. तो फंडामेंटल डेविएशन क्या आ गया दोस्तों? फर्स्ट फंडामेंटल डेविएशन लिखो तो -0.009. यस आर नो? ये गैप क्या है? -0.009. और फिर नेक्स्ट पूछ रहा है टॉलरेंस क्या है. देखो यहाँ पे ये चीजें पूछने के, लेकिन मैंने आपको बता दिया कैसे कैलकुलेट करना है. तो टॉलरेंस क्या होगा यहाँ पे? देखो टॉलरेंस अगर लिखना है तो मैं सिंपली लिख सकता हूँ 0.025 माइनस 0.009. इसका डिफरेंस ले लो, आपको यहाँ पे मिल जाएगा टॉलरेंस. यस आर नो? टॉलरेंस क्या है मेरा? दिस इज माय टॉलरेंस, करेक्ट? दिस इज माय टॉलरेंस. ये आपको डिवीजन दिया हुआ है 0.09. यस आर नो? करेक्ट? और ये आपके लिए क्या है? 0.025. तो 0.025 में 0.09 को सब्सट्रैक्ट कर दो, आपको मिल जाएगा क्या? टॉलरेंस. तो अकॉर्डिंग टू दिस हमारा आंसर क्या है? हमारा आंसर क्या है? टेल मी. ऑप्शन डी. ऑप्शन डी इज द राइट वन. यस, ऑप्शन डी इज द राइट वन. वेरी गुड. Okay, next, in an extrusion process, the billet is smaller in diameter than the chamber and is filled with a fluid. The pressure is transmitted to the billet by a ram. What is the process known as? Very good, very good. Yes, 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 correct, correct. Option A is the right answer. This is hydrostatic extrusion process. Hydrostatic extrusion process. You can see here in a hydrostatic extrusion process. This is our billet. Yes or no? And here we have dye. Yes or no? Here we have dye, and it is completely filled with liquid water. Then material get extruded like this. Yes or no? And through ram we can apply force, correct? So obviously this is called hydrostatic extrusion. Okay, which one of the following processes performed in powder metallurgy to promote self lubricating properties in the sintered part? This is very important question. मुझे लगता है कि हर एग्जाम में लगभग ये क्वेश्चन आपको देखने को मिलेगा ही मिलेगा. इज इट राइट? तो पाउडर मेटलर्जी का क्वेश्चन है, आप इसको ध्यान से देखो, बताओ क्या आंसर है. विच वन इज द राइट आंसर? विच वन इज द राइट आंसर? Yes, impregnation is the right answer. Impregnation is the right answer. Which of the following process performed in powder metallurgy to promote self-lubricating property? Actually, in impregnation process, the part produced by powder metallurgy, obviously we know that it has porosity. And now, if you dipped this porous part in the liquid oil or a lubricant, then that liquid lubricant can penetrate inside the porous part due to capillary action. Yes or no? So this process is called as impregnation. Similarly, if I talk about infiltration, in this the porous part is dipped into the liquid metal to reduce the porosity of the part. Yes or no? So this is called infiltration. So in infiltration we dipped our part in liquid metal. Yes or no? And in impregnation we dipped our part, powder metallurgy part, in lubricant lubricating oil or lubricant oil. Yes or no? Is it right? So this is the difference. और यहाँ इन दोनों से क्वेश्चन जरूर आपको देखने को मिलता है एग्जाम में. Okay, next, in orthogonal cutting process, rack angle of the tool is 22 degree and friction angle is 26 degree. Using merchant shear angle relation, the value of shear angle will be, tell me. तो मर्चेंट सर्कल का सोल्यूशन अगर आप यूज करोगे तो 25 प्लस बीटा माइनस अल्फा इज इक्वल टू 90 डिग्री. यस आर नो? अगर मैं इसको यूज करूं तो हमें क्या निकालना? शियर एंगल. सो सिंपली यू कैन से 25 इज इक्वल टू 90 डिग्री प्लस अल्फा माइनस बीटा. तो यहाँ से क्या आएगा? 90 माइनस व्हाट अबाउट अल्फा? द रैक एंगल इज 22 डिग्री, सो दिस इज 22 डिग्री माइनस व्हाट अबाउट बीटा? फ्रिक्शन एंगल इज 26 डिग्री एंड डिवाइडेड बाय 2 करो यहाँ से, तो सिंपली आपको क्या मिल जाएगा? 5. यस आर नो? सिंपली यू विल गेट द 5. यस आर नो? तो पहले यहां से ये बताओ 25 की वैल्यू क्या आती है? 25 की वैल्यू क्या आती है? यहाँ पे -4 आएगा. -4, 90 में -4 आएगा 86. यस आर नो? 86, तो यहाँ से 5 मिल गया, 86/2, that is 43 डिग्री, 43 डिग्री. So option C is the right one. Option C is the right one. Yes, Kapil, check once again. This is 41 or 43. So if you take difference of this 22 minus 26, so it gets -4. 90 minus 4, that is 86. 86 divided by 2. Tell me, is it right or not? 2 5 plus beta minus alpha. So 90 plus alpha minus beta. Alpha is 22 degree. Beta is 26 degree. Yes, Kapil, check again. Tell me, 43 is the right or not? Tell me. Yes, option C is the right answer. Very good. ऑप्शन सी इज द राइट आंसर. यहाँ पे ऐसी छोटी छोटी मिस्टेक नहीं करनी है. कई बार सिंपल क्वेश्चन देख के आप गलती कर जाते हो, ठीक है, तो सिंपल क्वेश्चन पे आपको स्पेशली थोड़ा सा कॉन्शियस रहना है. डायनोमीटर इज अ डिवाइस यूज्ड फॉर मेजरमेंट ऑफ. डायनोमीटर देखो, जब भी डायनोमीटर की बात करेंगे, इट इज मेनली यूज्ड फॉर मेजरिंग फोर्स. यस आर नो? तो फोर्स ड्यूरिंग मेटल कटिंग. ऑप्शन बी इज द राइट आंसर. फोर्स, ऑप्शन बी इज द राइट आंसर. इज इट राइट? In the tolerance specification 25D6, the letter D represents. The letter D represents. Tell me, which one is the right answer? Which one is the right answer? See, whenever we have this kind of things, so this represents nominal diameter, yes or no? Nominal size, correct? And this represents a type of fundamental tolerance, types of fundamental deviation, types of fundamental tolerance, sorry, fundamental deviation, not tolerance. You have seen like this. Here we have a zero line, exactly over this here we have H, capital H, yes or no? And exactly below this you have small h, correct? After that you can see here it is looking like this. This is F like this, yes or no? Correct? So actually this represents deviation. Is it right? Fundamental deviations, correct? And this 6 represents tolerance grade. 6 represents tolerance grade, that is IT6. This is IT6, yes or no? Correct. So the correct answer is upper deviation. Upper deviation is called as fundamental deviation in case of shaft, yes or no? Or if I talk about hole, this is upper deviation for shaft and lower deviation for hole. Let's see here. Let's suppose you have, this is a hole, is it right? This is a hole and this is tolerance, is it right? And this is basic line and similarly this is shaft, correct? So in this case you can see this lower deviation is a fundamental deviation for hole and this upper deviation is the fundamental deviation. This is upper deviation which is called as fundamental deviation and this is lower deviation which is also called as fundamental deviation. Yes or no? So and this 6 represents types of grade of tolerance. So here we need to find out the letter D represents. Is it right? Letter D represents. Here our question is letter D. And capital D, obviously if you see this is a capital D. So capital letter is always used for whole. Yes or no? Capital letters are always used for whole. Is it right? और अगर ये whole के लिए यूज होता है तो फंडामेंटल डेविएशन होल के लिए क्या है? लोअर डेविएशन. तो इसका करेक्ट आंसर होना चाहिए ऑप्शन सी. Is it right? The correct answer is option C. Hello? Actually, this letter represents deviation, fundamental deviation. Are you getting my point? This letter D represents fundamental deviation, and fundamental deviation for whole is a lower deviation. Is it right? And why I am taking lower deviation? Because this is a capital letter is always represented by whole and small letter is always represented by a shaft. Yes or no? तो यहाँ पे बहुत कई बार बहुत माइनर सा डिफरेंस होता है, आपको ध्यान रखना है और ऐसी गलती नहीं करनी है. इज इट राइट? अगर आप पे 6 पूछा जाता कि 6 क्या रिप्रेजेंट कर रहा है, तो आप सिंपली बोल सकते थे टॉलरेंस ग्रेड. बट यहाँ पे ये 6 के बारे में नहीं, या डी के बारे में पूछा जा रहा है, तो करेक्ट आंसर होना चाहिए ऑप्शन सी. इज इट राइट? ओके. विच ऑफ द फॉलोइंग ऑपरेशन डज नॉट यूजेस अ जिग? जिग्स किस पे यूज नहीं होगा? टर्निंग, ड्रिलिंग, टैपिंग, रिमिंग. ये तो ऑड वन आउट टाइप का क्वेश्चन है, वेरी सिंपल क्वेश्चन, ऑड वन आउट टाइप का क्वेश्चन है. इज इट राइट? Is that right? Tell me which one is the right answer. Which one is the right answer? Yes, option A is the right answer. That is turning. Option A is the right answer. That is turning. Yes or no? Because in drilling, trapping, and rimming, all these three operations we always use jigs. Is that right? Okay. Next, a diamond locating pins is used in jigs and fixtures because diamond locating pins is used in jigs and fixtures are. Tell me which one is the right answer. Diamond is very hard and wear resistance. It occupies very little space. It helps in assembling with tolerance on the center distance. It has a long life. So, which one is the right answer? Which one is the right answer? Tell me, which one is the right answer? It helps in assembly with tolerance on center distance. Yes, option C is the right answer. Yes, very good, Mukesh. R. Ram Prasad, very good. Option C is the right answer. Okay, in the 3 to 1 principle of fixtures design, 3 refers to, 3 refers to, tell me which one is the right answer. In 3 to 1 principle of fixtures design, 3 refers to the number of clamps required, locators on the primary datum face, degree of freedom of the workpiece, operations carried on the primary datum face. Yes, option B is the right answer. Locators on the primary datum face. You can see. Let's suppose you have an object like this, three-dimensional object like this, three-dimensional object like this. Is it right? So in the bottom face we put 3 locators, and in similarly in this we put 2 locators, and in this we put only 1 locators. Yes or no? So this is 3, this is 3, this is 2, this is 1. So 3 to 1 represents the locators, or simply you can say a pin. Yes or no? In CNC machine, feed drive a stepper motor with step angle 1.8 degree drives a lead screw with pitch of 2 millimeter. The basic length unit for this drive is, you need to find out basic length unit, and basic length unit is nothing but this represents the precision. Yes or no? Correct. So what is basic length unit? Let's see. Here I am giving you a hint. This is nothing but this is pitch over number of pulses. Number of pulses. If you remember this formula, then you will get the answer. Pitch over number of pulses. And how you calculate number of pulses? The step angle is 1.8 degree. So in one revolution, we have 360 degree, and every 1.8 degree we get one pulse. Every 1.8 degree we have, every 1.8 degree we have one pulse. Yes or no? So how many pulses are there? So 360 divided by 1.8, that is 200 pulses. If it is represented by capital P, यहाँ से आपको मिल जाएगा 200 pulses. Yes or no? So like this you can find out the pulses, and the pitch is already given here. What is pitch? 2 millimeter. So 2 by 200. So this is 1 by 100, or you can say 0.01. 0.01 millimeter, 0.01 millimeter. And if you want to convert, if you want to convert this into, if you want to convert this into micrometer, so you just multiply, because this is in millimeter, because this is in मिलीमीटर. अगर आपको इसको माइक्रोन में चाहिए, अगर आपको माइक्रोमीटर में चाहिए, तो आपको सिंपली क्या करना पड़ेगा, इस 0.01 को 1000 से मल्टीप्लाई कर दो, तो ये आपको बन जाएगा माइक्रोमीटर में. करेक्ट. 1000 से अगर हम मल्टीप्लाई करेंगे तो ये 10 माइक्रॉन्स आएगा, ऑप्शन ए 10 माइक्रॉन्स। ये बी ऑप्शन क्यों दे रहे हो बाल को, 20 माइक्रॉन्स नहीं 10 माइक्रॉन्स, 10 माइक्रॉन्स, यस राम प्रसाद 10 माइक्रॉन्स इज द राइट आंसर। मुकेश ऑप्शन बी नहीं होगा बालक, ऑप्शन बी नहीं होगा। ओके, ड्यूरिंग अल्ट्रासोनिक मशीनिंग द मेटल रिमूवल इज अचीव्ड बाय, अल्ट्रासोनिक मशीनिंग में मेटल रिमूवल कैसे अचीव करेंगे, विथ हाई फ्रीक्वेंसी एडी करंट, हाई फ्रीक्वेंसी साउंड वेव्स, hammering action of the abrasive particles, rubbing action between the tool and workpiece. This is ultrasonic machining. Obviously, hammering action of the abrasive particles. This is wrong answer. देखो, साउंड वेव्स हम यहाँ पे प्रोड्यूस करते हैं, साउंड वेव्स में क्या होता है, साउंड वेव्स की हेल्प से हम एब्रेसिव पार्टिकल को स्ट्राइक कराते हैं वर्क पीस से, साउंड वेव्स को हम स्ट्राइक कराते हैं वर्क पीस से, जब वो स्ट्राइक होगा तभी तो मेटल रिमूवल होगा। Okay, which of the following is non-conventional machining method does not causes tool wear? USM, ECM, EDM, anode mechanical machining process. So किस प्रोसेस में आपका टूल वियर नहीं होता? Tell me. USM ultrasonic machining, ECM electrochemical machining, EDM this is electric discharge machining process. यूएसए में टूल वियर होता है कपिल, यूएसए में टूल वियर होगा। यस, ईसीएम इज द राइट आंसर, ईसीएम इज द राइट आंसर, ईसीएम में कोई टूल वियर नहीं होता, तो ईसीएम इज द करेक्ट आंसर। यहाँ पे क्या होगा कि सपोज यू हैव अ टूल लाइक दिस इज योर टूल लाइक दिस एंड दिस इज योर वर्क पीस एंड इन बिटवीन यू पास इलेक्ट्रोलाइट, यस और नो, यहाँ से आप इलेक्ट्रोलाइट पास करोगे तो इलेक्ट्रोलाइट क्या करेगा, इससे रिएक्ट करके इसके मटेरियल को हाइड्राइड्स के फॉर्म में रिमूव करेगा एंड डिस्प्लेसमेंट के फॉर्म में रिमूव करेगा, यस और नो। करेक्ट है, इसमें टूल का कोई लेना देना नहीं, टूल का आपको वियर आउट नहीं होगा। अगर ये टूल वियर होगा तो एक्यूरेसी कैसे मिलेगी? करेक्ट है, तो ईसीएम इज द प्रोसेस थ्रू विच वी कैन मेक एनी डाइज और टर्बाइन ब्लेड्स, यस और नो, विथ वेरी हाई एक्यूरेसी। करेक्ट। ओके, a cutter breaks while cutting gears and in removed by the operator, which of the following represents this activity on the flow process chart? Tell me which one is the right answer, which one is the right answer? A cutter breaks while cutting gears and is removed by the operator. Which of the following represents this activity on the flow process chart? दिस इज ऑप्शन डी। देखो, जब कटर ब्रेक हो जाएगा, गियर ब्रेक हो जाएगा तो आपका ऑपरेशन स्टॉप हो जाएगा, उस टाइम गियर चेंज वगैरह की एक्टिविटी होगी, उस टाइम आपका वर्क नहीं हो रहा होगा, आपका वर्क है मशीनिंग करना, मशीनिंग नहीं हो रहा है तो यहाँ पे डिले हो रहा है। इज इट राइट? सो इसको, इस एक्टिविटी को हम रिप्रेजेंट करेंगे डिले से, दैट इज कैपिटल डी। Which tables shows the data about its set of single operation jobs to be machined in a milling machine? The optimum sequence that minimize the mean flow time is? यहाँ पे सीक्वेंसिंग का प्रॉब्लम है, सीक्वेंस आपको बताना है कि क्या होना चाहिए। करेक्ट है, और सीक्वेंस ऑपरेशन बताओगे शॉर्टेस्ट प्रोसेसिंग टाइम के रिस्पेक्ट में, इसे हम बोलते हैं एसपीटी। एसपीटी रूल के अकॉर्डिंग आपको यहाँ पे अरेंज करना है, तो सबसे कम प्रोसेसिंग टाइम लग रहा है किसका? थर्ड का, तो इसको राइट में लिखो। उसके बाद 6 का, इसके बाद 1 आएगा, उसके बाद 4, तो यहाँ पे देखो 4 आएगा, फिर उसके बाद कौन सा है 5, उसके बाद 5 देन 2। करेक्ट, तो शॉर्टेस्ट प्रोसेसिंग टाइम के अकॉर्डिंग अगर हम इसको अरेंज करें कुछ इस तरीके से, तो ऑप्शन सी आपको यहाँ पे मिलने वाला है करेक्ट आंसर। यस और नो? Okay, the standard time for an operation has been calculated as 20 minutes. The worker was rated at 80%. This is rating. If the relaxation and the other allowances were 25%, then the observed time would be, ये आपको बताना है क्या आंसर होगा, ऑब्जर्व टाइम निकालना है दोस्तों यहाँ पे। करेक्ट, देखो यहाँ पे जो स्टैंडर्ड टाइम होता है, दिस इज स्टैंडर्ड टाइम इज नथिंग बट दिस इज नॉमिनल टाइम, दिस इज नॉमिनल टाइम प्लस अलाउंसेस होता है। इज इट राइट? नॉमिनल टाइम प्लस अलाउंसेस। अब यहाँ पे जो नॉमिनल टाइम होता है दोस्तों, नॉमिनल टाइम ये होता है ऑब्जर्व टाइम, ऑब्जर्व टाइम इनटू रेटिंग, ऑब्जर्व टाइम इनटू रेटिंग। तो इसको सिंपली मैं क्या लिख सकता हूँ, टी एस इज इक्वल टू टी ऑब्जर्व टाइम इनटू रेटिंग आर प्लस अलाउंसेस, दैट इज ए। अब यहाँ पे देखो क्या लिखा है, स्टैंडर्ड टाइम इज गिवन हियर 20 मिनट्स, द वर्कर वाज रेटेड एट 80%, आर इज गिवन and allowance is given, that is 25%, allowance is also given, that is 25%. 25% of what? 25% of nominal time, yes or no? 25% of nominal time. तो सिंपली आप इसको लिख सकते हो, इसको आप लिख सकते हो नॉमिनल टाइम, नॉमिनल टाइम इन ब्रैकेट 1 प्लस 1 पर प्लस परसेंटेज अलाउंस, सो फ्रैक्शन ऑफ अलाउंस, ऐसे लिख सकते हैं, करेक्ट। तो सिंपली अगर मैं इस फॉर्मूला में इसकी वैल्यू पुट करूं तो क्या आ जाएगा, ये टी नॉट इन ब्रैकेट, सॉरी टी नॉट इंटू आर, नॉमिनल टाइम तो टी नॉट इंटू आर हो गया, टी नॉट इंटू आर दैट इज रेटिंग इन ब्रैकेट 1 प्लस अलाउंस क्या दिया 25%, तो 0.25। अब यहाँ पे इसकी वैल्यू पुट करके आंसर निकाल सकते हो। देखो ये 20 दिया हुआ है, हमें टी नॉट कैलकुलेट करना है, रेटिंग दिया हुआ है 80%, रेटिंग दिया हुआ है 80%, तो सिंपली हम लिख सकते हैं 0.8, ये आ जाएगा 1.25, यस आर नो। सो यहाँ पे टी नॉट क्या आ जाएगा दोस्तों, 20 ओवर 0.8, क्या आएगा ये 20 ओवर 0.8 इंटू 1.25, और इसको सिंप्लीफाई करते हैं तो यहां से रिजल्ट आता है, क्या रिजल्ट आएगा, अगेन दिस इज 20, आई थिंक दिस इज 20 मिनट, इसको चेक कर लो कैलकुलेशन में यही आ रहा है कि नहीं आ रहा है, 20 मिनट्स, यस 20 मिनट्स। अगर ये 20 मिनट्स आ रहा है देन अकॉर्डिंग टू दिस द करेक्ट आंसर इज ऑप्शन बी। तो ये एक बहुत फेमस क्वेश्चन मैंने देखा है, ऑब्जर्व किया है, जो बहुत एग्जाम्स में कई बार ये पूछा गया है, तो थोड़ा सा आप इसको ध्यान रखना, इज इट राइट। चलो नेक्स्ट, इन द बेसिक इकोनॉमिक ऑर्डर क्वांटिटी मॉडल फॉर द ऑप्टिमल ऑर्डर क्वांटिटी, क्या होना चाहिए बोलो, इन बेसिक इकोनॉमिक ऑर्डर क्वांटिटी मॉडल फॉर द ऑप्टिमल order quantity, holding cost is more than ordering cost, holding cost is less than ordering cost, holding cost is equal to ordering cost. Tell me which one is the right answer, which one is the right answer, tell me which one is the right answer, क्या आंसर होना चाहिए, यस ऑप्शन सी इज द राइट आंसर, वेरी गुड। देखो इकोनॉमिक ऑर्डर क्वांटिटी की अगर मैं बात करूं, इकोनॉमिक ऑर्डर क्वांटिटी की अगर मैं बात करूं, तो इकोनॉमिक ऑर्डर क्वांटिटी में आपका होल्डिंग कॉस्ट और ऑर्डरिंग कॉस्ट दोनों बराबर होना चाहिए, इज इट राइट, yes, तो करेक्ट आंसर इज ऑप्शन सी, सॉरी करेक्ट आंसर इज ऑप्शन सी, ओके। नेक्स्ट, द स्लैक ऑन द वेरिएबल वेरियस इवेंट्स एट क्रिटिकल पाथ ऑन द PERT CPM चार्ट, क्या होता है स्लैक, बोलो क्या आंसर होगा, द स्लैक ऑन वेरियस इवेंट्स एट क्रिटिकल पाथ ऑन PERT and CPM, yes correct, this is remain constant, this is remain constant, this is remain constant, this is remain constant, is it right, this is remain constant, okay. The assignment problem is, tell me which one is the right answer, integer valued at the optimal when solved by the simplex method, next not solvable by simplex method, the dual of the transportation problem, the dual of the maximum flow problem. The correct answer is the dual of the maximum flow problem. This is the assignment problem. Yes or no? So option D is the right answer. Okay. In piercing operation, shear and clearance is provided on. In piercing operation, shear and clearance is provided on. both on punch. Tell me. Both on punch. इन पियर्सिंग ऑपरेशन सीयर एंड क्लियरेंस, यस, हमेशा पंच को प्रोवाइड किया जाएगा। यस और नो। सीयर का मतलब क्या हुआ, देखो ये टूल इस तरीके से बनाया जाता है, इज इट राइट? अगर आपको पियर्सिंग करना है, मतलब पियर्सिंग का ऑब्जेक्टिव क्या है, होल बनाना। तो जब होल बनाना है तो हम किसको क्लियरेंस प्रोवाइड करेंगे? पंच को प्रोवाइड करेंगे। दिस इज माय क्लियरेंस, बोथ साइड वी ऑलवेज प्रोवाइड क्लियरेंस, इज इट राइट? दोनों साइड हम क्लियरेंस प्रोवाइड करेंगे और इक्वल क्लियरेंस होता है, इज इट राइट? और इसे जो आप देख रहे हो, ये जो कटिंग एज है वो टेपर बनाई गई, दिस इज कॉल्ड सीयर। तो दोनों ही किसको हम प्रोवाइड करेंगे? पंच को प्रोवाइड करेंगे, ना कि डाइस को। तो करेक्ट आंसर क्या होना चाहिए? ऑप्शन सी होना चाहिए। Okay, so this is all about my part. So after that, Vineet sir will continue. Rest of the जो भी टेस्ट में क्वेश्चंस है, रिमेनिंग अप्रोक्सीमेटली 42 क्वेश्चंस, वो विनीत सर कवर करेंगे, जिसमें एंटायर थर्मल सेक्शन होगा। सो ऑल द बेस्ट यू गाइस एंड वी विल मीट सून।
ओके, गुड आफ्टरनून स्टूडेंट्स। सो चलो कंटिन्यू करते हैं आपके पास यहाँ पे क्वेश्चन नंबर 44 से। सो बेसिकली अब जो क्वेश्चन आपके पास यहाँ पर है वो मेजोरिटी में थर्मल पार्ट को यहाँ पे कवर अप करेंगे, और उसके बाद यहाँ पे जो थ्योरी ऑफ मशीन का जो पोर्शन बचा है वो हम यहाँ पे कवर करने वाले हैं। ठीक है, अब आपके पास जो फर्स्ट क्वेश्चन है यहाँ पे क्वेश्चन नंबर 44, बेसिकली इसका यहाँ पे एक बार क्वेश्चन को आप रीड कर सकते हो, आपने ऑलरेडी रीड कर चुके हो। इसका क्वेश्चन आंसर यहाँ पे बताने की कोशिश करो, क्या आंसर होगा इस केस में। तो इस क्वेश्चन में क्या गिवन है आपके पास, यहाँ पे एक सिंपल सी कंप्रेशन प्रोसेस हमारे पास है, जिसमें 2 किलो जूल ऑफ मैकेनिकल वर्क आप सप्लाई कर रहे हो, एंड द फ्लूइड मास इज गिवन एज 4 kg. Okay, and the corresponding 800 joule of heat is being rejected from the system. So here you can see the amount of work is given to you as a 2000 joule. Okay, and it is negative because it is being supplied to the system, and the corresponding mass of the system is 4 kg. Okay, so here you can see the heat is rejected from the system. That means the heat is given to you as a minus 800 joule. Okay, and you want to calculate the change in specific internal energy. So you can easily calculate this by the first law of thermodynamics, which states that Q is equal to delta U plus W. So here you can see the Q is given to you as minus 800, and the corresponding value of U will come out to you as delta U is equal to plus 1200. Okay, but in this question we have to calculate the specific internal energy. Okay, and this is the total change in internal energy for which is related to the 4 kg of the fluid. So here you can see the corresponding, the change in specific internal energy will become 1200 divided by 4, that is 300 joule per kg. So here you can see the option number C will be the correct answer of this question. Okay, so now let's move to our next question, that is question number 45. In which of the following processes is there an increase in entropy with no degradation of energy? So can anyone provide me the answer of this question? Just wait a minute. Okay, so just tell me the answer of this question. Option number A, B, C or D, and please mention the question number also. So in which of the following process there will be an increase in entropy with no degradation of energy? Anyone? So see here, basically in the case of polytropic, isotonic and isobaric heat addition, whenever there is a heat addition process, heat addition or heat rejection taking place, there will be a corresponding change in temperature. That means there will be a finite temperature gradient. That means there will be a corresponding change in entropy, and there will also be a corresponding degradation of energy taking place. But in the case of isothermal expansion, the change in temperature will be equal to 0. That means there will be not finite temperature gradient. Okay, in that case the entropy will increase, but the corresponding degradation of energy will not be there. Okay, so the option number B will be the correct answer of this question. So now let's move to our third part. When the elements of the pair are kept in contact by the action of external forces, the pair is said to be, okay, so it's actually a very simple question, and which is related to our theory of machine subject. And in this case, so we have been using the action of external forces here. Okay, so that means it is a force closed pair. Okay, the option number D will be the correct in this case. Okay, so now let's move to our next part. Consider the following statement regarding the deaerator used in the steam power plant. So we have been provided with the two statements. That is, first statement is it is used to decrease the solubility of dissolved gases like oxygen and CO2. And the second statement is a direct contact type open pit water heater. So can anyone tell me the answer of this question? So here you can see, first of all, the main function of the deaerator is to decrease the solubility of dissolved gases. Okay, so basically the statement number one is a correct statement, and we normally use the deaerator in the case of the Rankine cycle as an open feed water heater. Okay, so here the option number C, that is both statement 1 and 2 will be correct in this case. Okay, that you have to understand. Students, please mention the question number. Okay, whenever you are trying to answer the answer, whenever you are commenting the answer. So in the question number 48, we have been provided with a steam power plant in which the heat input to the boiler is given to you as a 15 megawatt, and the corresponding efficiency of the boiler is 80%, and the calorific value of the fuel is given as 25 megajoule per kg. And we have to calculate the fuel burning rate in this question. Actually, this is a very simple question. Okay, just try to solve this question. In one step, you can easily solve this question. Student, be fast because you will not be having sufficient enough time for solving this question. You have maximum 1 minute. So basically, in this question, you can see the boiler efficiency is nothing but it is equal to the heat input to the boiler, which is given as 15 megawatt, and that I can write as 15 into 10 to the power 6, and the corresponding rate of burning of the fuel. So here I can say the fuel burning rate, let us say it is represented by m dot, and the corresponding calorific value as 25 megajoule. Okay, so here the efficiency is given to you as 0.8 here, that is 80%. So if you solve this question, you will get the value of the mass flow rate or fuel burning rate as 15 into 10 to the power 6 divided by 25 into 10 to the power 6 into 0.8. So if you solve this question, you will get the fuel burning rate. Okay, and maybe if you solve this question, you will get the answer as 0.75 kilogram per second. So that means the option number B will be the correct answer of this question. Okay, let's move to our question number 49. A spring mass system has an undamped natural frequency of 16 radian per second when spotting a mass of 5 kg if the system is critically damped. Okay, so now the system is critically damped. That means the Cc is given to you as 1 here. Okay, and the corresponding we have to calculate the damping coefficient. Oh, sorry, it is critical damped. So we have to we have been given that zeta is equal to 1 here, and we have to calculate the value of the damping coefficient. That is, we have to calculate the value of C here. Okay, so can anyone provide me the answer of this question? You have also been provided with the value of undamped natural frequency, that is omega n as 16 radian per second. So basically, if you see, in the case of a critically damped system, we already know that C by M is equal to 2 zeta omega n. Okay, but here the zeta is given as 1 because the system is critically damped. So here I can say the C will be equal to 2m into omega n. So here you can see the corresponding value of the m is given to you as 5 kg, and the corresponding value of omega n is given to you as 16. Okay, so that means the answer will be 160 Newton second per meter. Option number B will be the correct answer of this question. That is 49 number question. Okay, let's move to our next question. That is question number 50. Yeah. So basically, in the question number 50, we have been provided with a mass of we have been provided with a flywheel which is having a mass of 300 kg, and a corresponding radius of gyration is 1 meter here, and it is given a spin of about 100 rpm, and the correspondingly vertical axis of the whole assembly is rotating at the corresponding speed of 6 radian per second, and we have to calculate the corresponding gyroscopic couple which is experienced by the system. So basically, you already know that the gyroscopic couple is given by I into omega p. Okay, that's the formula of the gyroscopic couple. So here you can see the corresponding I will be written as the mass into the corresponding square of radius of gyration, that is 300 into 1 square, and the corresponding value of omega. Omega you can easily calculate by this expression 2 pi into 100 by 60, and the omega p is given to you as 6 radian per second. Okay, so if you solve this part, you will get your answer as 6,000 Newton, 6,000 pi Newton meter. Okay, so here I can say the answer will be 6 pi kilonewton into meter. Manish, your answer is correct. Option number B will be the correct answer of this case. Okay, so see here in the question number 51, we have been provided with the regenerative Rankine cycle. Okay, and the corresponding enthalpies are given at different points, that is H1, H2, H3, and H4. We have to calculate the total amount of heat supplied to the boiler. It's a very nice question actually. Okay, and here just see, we have to neglect the pump work. Just try to solve this part. It's a very interesting question actually. So if you see in this question, we have to calculate the heat supplied. Okay, and it is a case of a regenerative Rankine cycle. So here you can see the correspondingly the fluid is entering into the boiler at point number 7 and it is exiting the boiler at point number 1. So here I can say the corresponding amount of heat supplied is equal to H1 minus H7. So that means in order to calculate the heat supplied in the boiler, we have to calculate the enthalpy at point number 7. Okay, so here you can see, if you want to calculate the enthalpy at point number 7, then first of all we have to calculate the enthalpy at point number 6 by doing the energy balance. Okay, so here if I do the energy balance in the case of regenerator, so here you can see the corresponding energy balance will be, so here you can see the enthalpy at point number 2, which is having a flow rate of 0.25 second kilogram per second, is mixing with the 0.75 kilogram per second of steam at point number 5. So here I can say the 0.25 into H2 plus 0.75 into H5 is equal to H6. Okay, so here first of all just understand, we have to neglect the pump work. So basically if the pump work is neglected, so here I can say the corresponding value of the enthalpy at point number 4 is nearly equal to the enthalpy at point number 5. Okay, and the correspondingly value of the enthalpy at point number 6 is nearly going to be equal to enthalpy at point number 7. Okay, so just put all the values into this expression and get the value of H6 here. So here you can see the corresponding value of H6 will be 0.25, and you know the value of H2 as 2700, and so here you can see the corresponding value of enthalpy of H5. H5 is equal to the H4. Okay, so here multiply by 200. So just get the value of this H6. Okay, and once you get the value of H6, just put the value in this expression and you will get the corresponding value of the amount of heat supplied into the boiler. Okay, so in that case, the answer which you are going to get in this case will be the option number C, that is 2575 kilojoule per kg. Okay, you just have to calculate this value of the enthalpy at point number 6, and then you have to put this value into this final expression of the heat supplied into the boiler. Okay, Mani, it's not question number 60, it is question number 51. Okay, let's move to our question number 52. So see here in question number 52, we have been provided with the 4-link mechanism in which the dimensions of the links are given to you in the standard unit of length, and we have to see what type of mechanism it is. Okay, so here you can see in out of the 4 link, the corresponding link number, link number 3 is the shortest link, which is having a length of 4 meter, I can say. Okay, so here you can see if the shortest link is opposite to the fixed link, in that case the corresponding input and output of the link will be the rocker. That means it is a double rocker mechanism. The option number B will be correct in this case. It's a very simple question actually. So here you can see if the shortest link is attached to the adjacent to the fixed, in that case the corresponding mechanism will be going to be equal to crank rocker, and once it is fixed here, then it will be going to be a double crank. Okay, so here the question number 53. Just read this question and try to answer this question. It is a very nice question actually. and also one of the simple question of this test series. So basically in this question, what have been provided to you, in a mercury steam sulfur dioxide cycle, heat rejected in the mercury cycle is given to the steam cycle. Okay, so basically it is a combination of three cycles, that is mercury steam sulfur dioxide cycle, and the heat rejected in the mercury cycle is given to the steam cycle, and the heat rejected from the steam cycle is utilized in the sulfur dioxide cycle, and the corresponding efficiency of all the cycles are given to you. The individual efficiencies of all the cycle 0.5, 0.4 and 0.25, and you have to calculate the overall efficiency of the composite cycle. So can anyone provide me the answer of this question? Just try to solve it. So just remember, so whenever you want to calculate the overall efficiency, in that case, just see the overall efficiency and the corresponding efficiency of the individual cycles are related by this formula. That is 1 minus overall efficiency is going to be equal to the product of 1 minus individual efficiencies of all the cycle. So here you can see 1 minus 0.5, 1 minus 0.4, 1 minus 0.25. Okay, so if you solve this part, you will get 1 minus 0.225. Therefore, the corresponding efficiency of the overall cycle will be equal to 0.775. That means the option number A will be the correct answer of this question. Okay. So let's move to our next part. Question number 54. For the two paths are shown in the figure, one reversible and one irreversible. Okay. To change the state of the system from A to B, some options are given here. So just see here, A is the initial state and B is the final state, and we have been moving from state A to state B by corresponding two paths. One is irreversible and the second one is reversible here. And say, so first of all, one thing is clear that out of these, for both of these processes, the corresponding heat transfer and the corresponding work transfer will going to be different, because these two quantities are basically the path function. Okay, and the corresponding change in energy is going to be remain same, because it is a point function. It depends upon only on the initial and final states. Okay, so here I can say the delta U will be the same in this case. Mani, your answer is correct. That is option number B. Delta U is same for this case, and Q and W are going to be different. Okay, so next question is, which one of the following represent the condensation of a mixture of a saturated liquid and saturated vapor on an enthalpy entropy diagram? Okay, can anyone provide me the answer of this question? अंकित, अभी HPCL का कल एग्जाम आ रहा है, थोड़ा सा उस पे तो फोकस करने की कोशिश करो इस टाइम पे. चार्जेस है वैसे आपके पास यहाँ पे 125, अगर आप यहाँ पे 125 में से 94.5 अगर आपके पास आते हैं तो इस केस में देखो आपके पास यहाँ पे एंथैल्पी एंट्रोपी डायग्राम बेसिकली क्या चीज है, यहाँ पे आपके पास मोलियर डायग्राम है. ठीक है, और मोलियर डायग्राम के अंदर अगर हम यहाँ पे बात करें कंडेंसेशन प्रोसेस को अगर मैं शो करना चाहता हूँ सैचुरेटेड लिक्विड से सैचुरेटेड वेपर लाइंस, तो इस केस में आपके पास यहाँ पे इसे हम शो करते हैं इंक्लाइन लाइन ऑफ कांस्टेंट स्लोप से. ठीक है ना, बिकॉज आपके पास जो कंडेंसेशन प्रोसेस होगी सैचुरेटेड लिक्विड से सैचुरेटेड वेपर, वो आपके पास यहाँ पे कैसे होगी, कांस्टेंट प्रेशर पे होती है या कांस्टेंट टेंपरेचर आप बोलो उसे. तो इस केस में हमारे पास जो स्लोप होगा बेसिकली वो कैसे स्लोप आपको देखने को मिलता है, इस तरह से. ठीक है, तो इस केस में अब हमारे पास 55 में अब जो स्लोप फॉलोइंग जो प्रोसेस होगी वो रिप्रेजेंट होगी एक इंक्लाइन लाइन से, जो कि कांस्टेंट आपका स्लोप पर यहाँ पर है. इसको आप इस वे में भी देख सकते हो हमारे पास कि यहाँ पे अगर हम यहाँ पे देखें TDS इज इक्वल टू DH माइनस VDP. ठीक है, तो बेसिकली जो कंडेंसेशन प्रोसेस है वो कांस्टेंट प्रेशर पर है, तो DP की वैल्यू 0 है, तो दैट मींस आपके पास यहाँ पे DH बाय DS का जो स्लोप आपको देखने को मिलेगा एट कांस्टेंट प्रेशर, वो क्या किसके इक्वल होगा, टेंपरेचर के इक्वल होगा. अब कंडेंसेशन प्रोसेस में अगर टेंपरेचर कांस्टेंट है दैट मींस आपके पास स्लोप जो है वो इंक्लाइंड और आपके पास कांस्टेंट स्लोप आपके पास यहाँ पे होगा. ठीक है, इसका आपको यहाँ पे ध्यान रखना है. तो ऑप्शन नंबर बी विल बी द करेक्ट आंसर. Okay, the equation dq is equal to du plus pdv is true for. Okay, तो फर्स्ट ऑफ ऑल यहाँ पे देखो, जब भी कोई थर्मोडायनेमिक्स से इस तरह के क्वेश्चन काफी सारे आपसे पूछे जाते हैं. ठीक है ना, कि फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स को जब डिफरेंट डिफरेंट फॉर्म में रिप्रेजेंट करते हैं कि कौन सी इक्वेशन कहां पे वैलिड होगी। जिस तरह से अगर आपके पास इस क्वेश्चन को फ्रेम किया जा सकता है, del q इज इक्वल टू डी प्लस डी डब्ल्यू डी ई प्लस पी डी वी, ठीक है, डी यू प्लस डी डब्ल्यू डी यू प्लस पी डी वी। तो सबसे पहले आपको इस चीज में यहाँ पे ध्यान रखना है, इफ the du is mentioned, that means it is representing the closed system, okay, and the pdv work is only possible in the case of reversible process, okay, that you have to understood. So basically here you can see, basically this equation is representing the closed system, okay, but only for the reversible process, because here the work is mentioned as a pdv. but अगर यहाँ पे अगर pdv की जगह simply dw होता तो उस केस में आप यहाँ पे इस इक्वेशन को रिवर्सिबल एज वेल एज इरिवर्सिबल किसी भी प्रोसेस के लिए आप यूज कर सकते हो, ओके। सो अकॉर्डिंग टू दिस पर्टिकुलर इक्वेशन द ऑप्शन नंबर डी विल बी द करेक्ट। तो 56 का आंसर जो आपके पास होगा यहाँ पे, क्लोज सिस्टम ओनली रिवर्सिबल प्रोसेसेस आपके पास यहाँ पे होगा। इन केस अगर मैं आपके पास इक्वेशन को इस वे में मेंशन करता हूँ, dq इज इक्वल टू du प्लस dw, उस पर्टिकुलर केस में क्लोज सिस्टम एनी प्रोसेस, तब आपके पास ऑप्शन नंबर सी करेक्ट रहेगा। अगर आप यहाँ पे इस ढंग से इक्वेशन को मेंशन कर रहे हो तो आपके पास जो इक्वेशन है वो ओपन सिस्टम, वो किसी भी सिस्टम के लिए आप यूज कर सकते हो, और चाहे रिवर्सिबल प्रोसेस हो या इरिवर्सिबल प्रोसेस के हमारे पास क्यों ना हो, ओके। सो क्वेश्चन नंबर 57, which of the following is not true in respect of ideal refrigerant? So we have to mark the incorrect statement out of this. Okay, so first option is high latent heat of vaporization and specific heat, critical pressure and temperature well above the maximum operating pressure. So basically the option number B is perfectly correct, is the correct statement. Low value of specific volume, yeah, that is also correct. High volume of thermal conductivity, that is also correct. Okay, so here you can see, for in the case of ideal refrigerant, it should be, it is much better if it has a high latent heat of vaporization, but the specific heat, this particular specific term is not correct here. Okay, so here I can say the option number A will be the incorrect statement out of these four. Okay, because in the case of आप ऐसा समझ सकते हो जैसे रेफ्रिजरेंट अगर लिक्विड फेस में है तो वहां पे स्पेसिफिक हीट हमें डिफरेंट चाहिए, अगर आपका सिंपली अगर रेफ्रिजरेंट वेपर फेस में है तो वहां पे स्पेसिफिक हीट डिफरेंट चाहिए, ठीक है ना। तो इसका आपको यहाँ पे ध्यान रखना है। तो ऑप्शन नंबर ए जो है वो इनकरेक्ट है इस केस में यहाँ पे, ओके। तो ये थोड़ा सा अंडरस्टैंडिंग वाला क्वेश्चन है, मतलब अगर आपके कंसेप्ट बिल्कुल ही क्लियर है, ओके, so if you are clear with your all concept, then you can easily calculate the corresponding mass of air in this question. Okay, so what have been provided in this question? We have been provided with a room which is having a dimension of 7 into 4 into 4 meter. So here you can see the corresponding dimension of the room are 7 into 4 into 4. Okay, and we have been said that it is occupied by an air water vapor mixture which is having a temperature of 38 degrees Celsius, and the corresponding atmospheric pressure is 1 bar, and the relative humidity is given to you as 70% here. Okay, and we have to calculate the mass of air present into the system. Okay, first of all, just understand, it is mentioned in the question this that the atmospheric air is not saturated air. Okay, it is not saturated, it is unsaturated air because it is having a relative humidity of 70%. So here I can say the corresponding vapor pressure of the water vapor present in the air is going to be equal to as phi into PVS. So here you can see the phi is given to you as 0.7 and the corresponding value of PVS is given to you as 0.06624. Okay, so from there you can easily calculate the value of vapor pressure here. Okay, and what you have to calculate? You have to calculate the value of the mass of air now. So here you can see, let me calculate this value for you. The answer you are going to get for this particular vapor pressure is going to be equal to 0.046368. The vapor pressure of this is coming out to be around 0.046368. That's the amount of the vapor pressure here. Vapor pressure of the water vapor. Okay, so now here you can see, if the total pressure is given to you as 1 bar and the corresponding vapor pressure is given to you of water vapor is given to you as this case, so that I can say the corresponding vapor pressure of the dry air is going to be equal to as total pressure, I can say, minus vapor pressure, 1 minus 0.46368. So here you can see the corresponding, it will provide you the value of, just wait a minute, it will provide you the value of the vapor pressure of the dry air present in the room, and this value will come out to be around nearly, okay, I don't have this particular value, I'm just writing the final expression. So here you can see the corresponding value of the mass of dry air. You can easily calculate by using this expression, PA into total volume divided by R into temperature. Okay, so here you already know that the PA is going to be equal to this, that is 1 minus 0.04638, and the corresponding volume is given to you as 7 into 4 into 4, and we have been calculating the mass of the dry air here. So here the R is mentioned to you as 0.287 for dry air, and the corresponding temperature is given to you as 38 plus 273. Okay, so here you can see the answer. If you try solving this question by putting all these values, you will get as 119.7. Okay, so see here, actually there is very large calculation in this case. Okay, the calculation is little bit complicated in this case. So first of all, जैसा मान लो, ऐसा assume करो, अगर क्वेश्चन फ्रेम आपके पास होता है कुछ इस वे में, तो ऐसे केस में सबसे पहले आप गो थ्रू करो ऑप्शंस को. अगर ऑप्शंस में काफी ज्यादा वेरिएशन है, ओके, इफ देयर इज अ लॉट ऑफ वेरिएशन बिटवीन द ऑप्शंस, तो उस केस में आप क्या कर सकते हो, इसको बाय अप्रोक्सीमेशन सॉल्व कर सकते हो. इन केस अगर ऑप्शन बहुत क्लोज है, जैसे लेट अस सपोज अगर मैं आपको ऑप्शन प्रोवाइड करता 119, 117, 112 और 115, तो उस केस में आप स्किप करोगे तो ज्यादा बेटर है. ठीक है ना. अगर आप इस केस में देखो ऑप्शन जो है उसके अंदर काफी वाइड डिफरेंस है, तो अगर आप अप्रोक्सीमेशन से भी करते हो तो दैट मींस आप करेक्ट आंसर को आराम से रीच कर जाओगे. ठीक है, तो इसके केस में आप इस क्वेश्चन को आप अटेम्प्ट कर सकते हो इजीली, बिकॉज इसमें आपके पास यहाँ पे ऑप्शन में वेरिएशन काफी ज्यादा गिवन है आपको. ओके, now the next question is the reason for a person feeling more comfortable on a warm day if seated in front of an electrical fan is that, okay, the answer of this question will be, can anyone provide me the answer of this question? So just see here, in that case the person feel more comfortable. Why? Because there are more heat loss by means of convection and also due to the evaporation. The option number B will be the correct case in this. Option number B will be the correct answer of this question. Okay, so next question number 60 here. So in this question we have been provided with the wall through which the heat is getting conducted, okay, and it is having a thickness of delta here, and we have to mark the incorrect statement among these four. Okay, so here you can see the first statement is delta by K is known as thermal resistance. That is perfectly correct. Okay, the Ka by delta is known as a thermal conductance. Yeah, actually the thermal resistance in the case of conduction heat transfer is given to you as thickness divided by conductivity into area, and the reciprocal of this thermal circuit is basically known as a thermal conductance. Okay, and the next thing is Q by A. Q by A is also known as the thermal loading and is also called as a heat flux. Okay, so that means the statement number A, B, C are correct here. Okay, so now see, the basically in the case of conduction heat transfer, the temperature gradient is always negative. Okay, because according to the second law of thermodynamics, the heat always flows from the high temperature to the low temperature. That means the option number D will be correct. Okay, and in order to make the dt by dx as positive, we have to use this negative sign here in the final expression. Okay, that you have understood. Okay, so the next question is question number 61. The temperature distribution in a cylindrical rod with a heat generation is given by, okay, so actually this is a very direct formula based question. Okay, in the case of a cylindrical rod with having a heat generation, the direct variation of the temperature with radius is given by this formula, Qg r square divided by 4k 1 minus r square upon capital R plus Tw. Okay, that's the general expression for calculating the temperature distribution in the cylindrical rod with the corresponding heat generation. Okay, so the question number 62. The non-dimensional number known as Stanton number is basically used in the case of, okay, so see here, whenever you study the convection part of the heat transfer, in that case, the Stanton number is defined as the ratio of Nusselt number to the product of Reynolds and the Prandtl number. Okay, so basically this case this number is specifically studied in the case of a forced convection, because here we are dealing with the Reynolds number. Okay, and this case is a particular case of a flow over a flat plate. The option number A will be the correct answer in this case. Okay. Okay, just calculate the shape factor of this in this case. It's a very simple question. For the two long concentric cylinder. Okay, just make sure whenever this type of question arises, in that case, just make sure whether it is a cylindrical, whether it is a cylinder or it is a sphere. Okay, because sometimes the student take it as a sphere and just do the calculation, but by assuming it as a sphere, and they will get the wrong answer. Okay, so here it is mentioned that it is a two long concentric cylinders. So here I can say the corresponding area will be equal to pi dl pi d1l, and the corresponding area of the cylinder number 2 will be pi d2l here. ओके तो इस केस में अगर आप यूज करोगे कैलकुलेट करोगे सिंपली शेप फैक्टर f22, सो हियर यू कैन सी फर्स्ट ऑफ ऑल a1 f12 is going to be equal to a1 f12 is equal to a2 f21. ओके तो यहां से आप कैलकुलेट कर सकते हो सिंपली f21 जो कि मेरे पास आएगा a1 डिवाइडेड बाय a2. ओके बिकॉज f12 क्या है हमारे पास यहाँ पे 1 है. तो इस केस में अगर हम f22 की बात करें, f22 क्या होगा सिंपली f22 होगा 1 माइनस f12. दैट मींस द ऑप्शन नंबर सी विल बी द करेक्ट आंसर ऑफ दिस केस. ओके सो नेक्स्ट क्वेश्चन इज the insulated tip temperature of a rectangular long fin having an excess temperature over the excess over the ambient room temperature theta naught is. Okay, so basically it is a question from the fin which is having a case of insulated tip case. Okay, so see here, whenever the question arises from the fin, okay, just see which case is there. So it is a case of insulated tip. Okay, and in the case of insulated tip, we already know that the ratio of the excess of temperature, that is T minus T infinity divided by T naught minus T infinity, is given to you as cos of H m L minus x divided by cos of H ml. Okay, so here what you have to calculate, you have to calculate the insulated tip temperature. That means you have to find out the temperature at this tip. So can I say that if you want to calculate the value of theta, okay, at the tip, then you have to put the x as L. Okay, so if you put the value of x as L, in that case you can see L minus L will become 0 and hyperbolic cosine will become 1. So here I can say the corresponding value of the insulated tip temperature having an excess theta is going to be equal to theta naught divided by cos H ml. The option number D will be the correct answer in this case. Okay. Okay, so next question is question number 65. The main advantage of the two-stroke engine over the four-stroke engine is, okay, so just see what are the various advantages of the two-stroke engine over the four-stroke engine. Can anyone provide me the answer? What will be the answer of this case? So basically in this case, in the case of two-stroke engine, actually there will be more uniform torque, okay, and there will be a corresponding power output will be more, okay, and there will be absence of valve also. That means all of these options, basically option number A, B, C, are the given advantages of the two-stroke engines over the four-stroke engines. So option number D will be the correct here. Next, question number 66. The desirable characteristics of the combustion chamber for the SI engine to avoid knocking. Okay, so just see, in order to avoid the knocking in the case of SI engine, we have to make sure that the cylinder dimension is very small. That is, the diameter of the bore of the cylinder is very small. Okay, so that means option number A is correct. Okay, and the next thing is the short ratio of flame path to the bore, that is also correct. Okay, and the next thing, the absence of hot surfaces in the last region of the chart, that is also correct. That means the option number D will be the correct answer of this case. Okay, all of these statements are the desirable characteristics for the combustion chamber in order to avoid the knocking in the case of SI engine. Okay, so next question is, in the case of SI engine, alcohol is the major source for the emission of. Okay, so see here, in the case of engines, we have a different types of the emissions. Okay, and out of this, alcohol is the major source for the emission of the aldehyde in the case of SI engines, basically. Okay, so option number B will be the correct case. Okay. So is there any problem till now? So now we are going to move to our next question, that is question number 68. we have been provided that that the engine has a 40 kilowatt. There is a engine which is having a 40 kilowatt brake power and is having a mechanical efficiency of 80%. So here it is given that the mechanical efficiency is 80% and the corresponding brake power as 40 kilowatt. So you already know that the mechanical efficiency is basically the ratio of the brake power to the indicated power. Okay, so here I can say the corresponding value of the indicated power is 40 divided by 0.8, that means 50 kilowatt. Okay, so the corresponding indicated power will be equal to 50 kilowatt. So now we have to calculate the approximate value of the mechanical efficiency at 50% of the rated load. So see here, when the rated load is reduced to half, in that case the brake power is also going to be changed, okay, by a factor of 50%. So initially the brake power is given to you as 40 kilowatt. That means the new brake power will be equal to 20 kilowatt. Okay, no matter what is the rated load, okay, the friction power is going to be remain same. That means initially if you see the correspondingly, initially the friction power is equal to 50 minus 40. So here I can say that initially the frictional power is going to be equal to 10 kilowatt. So here also when you run the engine with 50% of rated load, in that case the friction power is going to be equal to 10 kilowatt. So here I can say the correspondingly mechanical efficiency is going to be equal to brake power, new brake power, that is 20 kilowatt, divided by new indicated power, that is 30 kilowatt. So here I can say the corresponding value of the mechanical efficiency will become 66.67%. Okay, simply the ratio of 2/3. So option number C will be the correct answer of this case. Okay, so now see question number 69. If the Mohr circle is drawn for a fluid element which is inside a fluid body at rest, it would be okay. So first of all, just understand here the fluid element is at rest, okay, and the fluid element is taken inside a fluid. So let us suppose if we have been provided with a container which is having a liquid, which is in a static position. So here you can see. Let us say we have an element here. Okay, so here you will see this element will be subjected by some fluid pressure, and it will exert the normal compressive stresses on the fluid element. So if I draw simply the Mohr circle, okay, so if you see on this element the normal compressive forces are acting. Okay, so that means the Mohr circle will be represented by this point. There will be no shear stress on this case. Okay, so here I can say if the Mohr circle is drawn, in that case it will be represented by a point on the normal stress axis. That means the option number C will be the correct answer of this question. Okay, so the next question is question number 70. So just see, we have been provided with a rectangular water tank. Let us say we have been given a rectangular water tank which is having a ratio of length, breadth and height as 2:1:2. That means it is equal to 2, let us say 1, and it is equal to 2. And we have to calculate the value of the ratio of the hydrostatic forces on the bottom. Okay, so see here, this is the bottom surface and to that of any large vertical surface. Okay, so if you see, we have to calculate the ratio of the force on the bottom divided by force on the any surface which is having a larger surface area, and the correspondingly value of the force, hydrostatic force, is given by W A x bar. That is the final expression. Okay, so here you can see the amount of liquid, the specific weight of the liquid is same in this case. So that means the omega will be same. Okay, the specific weight of the liquid is going to be remain same. Now the area of the bottom surface is nothing but it is equal to 2 into 1. The area of the bottom surface is 2 into 1 here. Okay, and the correspondingly height from the top to the centroid of this area is going to be equal to 2 here. That is, so here I can say it is 2 into 1 into 2 divided by area of the large vertical surface. So here you can see the area of the large vertical surface will be equal to 2 into 2. Okay, so the corresponding area will be 2 into 2 and the corresponding x bar. So here you can see this front area and this is the backward area is the basically the large vertical area here. Okay, so here if you see the correspondingly value of the x bar here will going to be equal to 2 by half. That means 2 by 2. So if you see the ratio will come out to be equal to 1:1. Okay, so that means the option number B will be the correct answer of this case. That you have to understand. Okay, so the next question is in a turbulent flow in a pipe, the shear stress is basically okay. So just see in this case, suppose if there is a pipe and the fluid is flowing through it, and suppose if the flow is laminar, if the flow is laminar, in that case the shear stress varies in this way. The correspondingly value of the shear stress at the center is 0 and the corresponding shear stress at the surface is maximum and the variation is linear. Okay, and the corresponding velocity profile is parabolic in nature. But similarly, in this case, if the flow is turbulent here, if the flow is turbulent, in that case, the correspondingly the variation of shear stress will going to be remain same. That means the shear stress will be maximum at the surface and the correspondingly value of the shear stress at the center will going to be 0, but the corresponding variation is also linear in nature. Okay, and where the difference is here, the correspondingly velocity profile will become something like that. That means the velocity varies logarithmically in this case. Okay, good afternoon Akhil. Okay, YS. Yeah, for the turbulent, in the case of turbulent flow, we normally use the 1/7 power law. Okay, and there is also a one law, that is logarithmic variation of the velocity profile. So see here, in the case of turbulent flow in a pipe, the shear stress is maximum at the wall, and it decreases linearly to a 0 value at the center. That means the option number D will be the correct answer of this case. Okay, the option number D will be the correct answer of this case. Okay, so here's the next question. The shear stress developed in a lubricating oil viscosity 9.81 poise filled between two parallel plates, which is having a thickness of 10 centimeter and it is moving with a relative velocity of 2 meter per second. So here, simply we have to use the Newton law of viscosity in this case. Okay, so just use this expression and provide me the answer. Just try to solve this part. So here you can see the viscosity is given to you as 9.81 poise, just convert it into the SI unit, that is 0.981. And the correspondingly change in velocity is given to you as 2 meter per second. And the dy is given to you as 10 centimeter, that means 0.1 here. Okay. So you just don't have to calculate this value, just solve this. Just you can here see that the answer will come out to be around 19 point something. So that means the 19.62 will be the correct answer of this case. Option number B will be the correct answer of this question. Okay, so that is the question number 73. The thickness of the turbulent boundary layer at a distance x from the leading edge over a flat plate. Okay, so see here. So here we have a flat plate over which the fluid is flowing. Okay, so if the flow is laminar, in that case you have seen, yeah, we have to see the variation of thickness of the boundary layer now. So see here, in the case of laminar, the boundary layer thickness varies as 5x divided by Reynolds number to the power x. That means the boundary layer thickness varies with the x as 0.5 here. But in the case of turbulent flow, this delta is given as 0.059 divided by Reynolds number to the power 4 by 5 here. Okay, so here I can say the correspondingly variation will be equal to delta is directly proportional to x to the power 4 by 5. Okay, so the answer will be equal to option number C here. Okay, that you have to see. In the case of 73 question, the answer will be x to the power 4 by 5. Okay, so now let's move to our next question, question number 74. So see here we don't have a sufficient time. Okay, so we have to solve a lot of question in a given time frame. Yeah, it is 1.5. No, it is 4 x to the power 4 by 5 here. Okay. Oh, just see here in the denominator it is 1 by 5 here. Sorry. In the denominator it is 1 by 5, and the correspondingly variation of the delta with respect to x is raised to the power 4 by 5. That you have to remember. Okay, the question number 74. Here in question number 74, we have been provided a U-tube manometer, which is attached to an air pipe, which is reading a height of 20 centimeter of the mercury, and we have to calculate the corresponding value of the pressure in the case in the air pipe in kilopascal. So actually a very simple question. We normally have to use the hydrostatic pressure law in order to convert the meter of mercury into the corresponding kilopascal. So here you can see, according to the Pascal law, pressure can simply be written as rho gh. Okay, so here you can see the value is given to you as 20 centimeter of mercury. Okay, so here you can see we have to use the correspondingly value of the density value of the mercury here. So the density of the mercury is 13,600, and the correspondingly value of the gravity is 9.81, and the height is given as 0.2 here. Okay, so just see. So basically in this type of exam you don't have sufficient time to do the calculation. So here you can easily assume that this 9.1 is equal to around is approximated as 10 meter per second. So if you take it as a 10, you can easily calculate the value, and the correspondingly answer will come out to be around 26.7 something. Okay, that you have to understand. Okay, so now see here. In the case of question number 75, a liquid is of specific gravity 0.82 flows with a velocity of 4.43 meter per second. Its velocity head is given by. Okay, that's a very nice question actually. Okay, just try to solve this question and provide me the answer. That's a very nice question. You have to calculate the value of the velocity head here. Can anyone provide me the answer of this question? You have to just provide the value of the velocity head. So first of all, just see here. What is the meaning of velocity head? Velocity head is nothing. It is equal to v square by 2g. Okay, so you already know the value of the velocity here. That is 4.43 square divided by 2 into 9.81. So here you can see the square of 4.43 is something with something between 16 to 25, and divided by it is equal to 20. Okay, so here the answer will come out to be around option number C, that is 1 meter. Okay, so we don't have to perform all the calculations. You just get the answer by just approximating it. Okay, so next move toward our question number 76. So here, if the fluid jet is discharging from a 50 millimeter diameter orifice and it is having a 40 millimeter diameter at its vena contracta, then what will be the value of the coefficient of contraction here? So यहाँ पे coefficient of contraction basically क्या होगा? Coefficient of contraction का मतलब क्या होता है? Simply area of the vena contracta, area of the vena contracta divided by area of the orifice. Okay, so here you can see the area of the vena contracta can be written as pi by 4 0.04. I can say 40 square divided by pi by 4 into 50 square. So if you just simplify this expression, you will get the answer as 16 by 25, and it will be something equal to 0.64 here. Okay, so just by looking at the options, you can mark the correct answer here. Okay, so option number C will be the correct answer in this case. Okay, what will be the answer of question number 77? So see here, in the case of in the question number 77, we have to calculate the degree of freedom. It's a very simple question. So just see, for calculating the degree of freedom, we can simply use 3L minus 1 minus 2J minus H. That's the final expression. Yeah, you have to consider the redundant degree of freedom also. So there is one redundant motion, and we have to subtract it also. That is minus of f of r. Okay, so here you can see the correspondingly links are fixed link, second link, third link, and fourth link. So we have total 4 number of links here, and the joints are, here we have first joint, second joint, third joint. Okay, so here I can say the correspondingly binary joints are 3 here, and there is one more higher pair also. So here I can say the corresponding value of h is -1 here. Okay, and there is one more redundant motion, that is of roller here. Okay, because this motion is not affecting the degree of freedom. So here I can say it is a redundant motion, unnecessary motion here. So if you solve this part, you will get the answer as 9 minus 6 minus 1 minus 1. That means the degree of freedom will be equal to 1 here. Option number B will be the correct answer in this case. Okay, let's move to our next part. Question number 78. So theoretical question: in a steam power plant, the maximum temperature of the steam that can be used is fixed by a metallurgical consideration. Second point is quality of the steam at the turbine exhaust. YS, please just read the question very carefully. So we have to just make sure that why the maximum temperature. How can you fix the maximum temperature in the case of steam power plant? Okay, that you have to see. So in the case of steam power plant, the maximum temperature is fixed by the metallurgical condition of the turbine. Okay, and it does not depend upon the quality of the steam of turbine, quality of the steam at the turbine exhaust. Okay, the maximum temperature is not fixed by this point. So here I can say the option number A, that is only first statement is correct here. The statement number 2 is incorrect actually. Okay, so let's move to our next part. The question number 79. Which of the following statement regarding the fire tube boilers are correct? Basically a simple theoretical question. Okay, so see here, in this case, they have a quick response to load changes, that is correct. They have a very large water storage capacity, that is also correct. And they have low fire cost. Option number D, that actually all of the correct statements are correct here in this case. Okay. Okay, so question number 80. Question number 80 is very nice. In a balancing of 4-stroke, 4-cylinder inline engine, the firing order helps to control the magnitude of. So by defining the firing order, are we balancing the primary forces only, or are we also balancing the primary couples? Both primary and primary couples? That's what you are trying to say? Okay. So first of all, just see here, there is a misconception actually. By defining the firing order, you are actually balancing the primary couples only. No matter what is the firing order is, the primary forces are always balanced. Okay, so in order to make sure that the primary couples are balanced, we have to define the proper firing order. Okay, so here in the question number 80, the firing order basically helps you control the magnitude of only primary couples only. So that you just understand this question, that is very important. Okay, because in the case of this, because the firing no matter what is the firing order, the primary forces are normally balanced. Okay, so in order to balance the primary couple, we have to define a particular defined firing order. Well, that's why it is used to control the magnitude of the primary couples only. Okay, so see here in the question number 81, thermal conductivity of a material depends upon temperature only. Second, for the quick response of a heat energy in any medium, the thermal diffusivity must be high. Okay, so if you have seen my demo class, in that case I have already told that the thermal conductivity depends upon many parameters. It is not depending upon temperature only, it also depends upon the material composition, moisture content also. Okay, and also the temperature. So that means the statement number 1 is incorrect here. And there is one more term in case of heat transfer we normally study, that is thermal diffusivity, which tells you about the response time, which gives you an indication about the response time of the system actually. Okay, so actually for the quick response of the heat energy in any medium, the thermal diffusivity parameter, which is defined as the ratio of the thermal conductivity to the heat storage capacity, has to be very high. So that means the statement number 2 is only correct. That means the option number B, 2 only, is correct here. Okay, so 82 number question. Actual modern diesel engine cycle resemble more closely to. Okay, so see here in the modern diesel engine, The cycle is more similar to the dual cycle here. The statement number, actually option number C is correct here. Okay, so next question is, the vertical rectangular wall with a width of 20 meter and a height of 12 meter is holding a 7-meter deep water body. The line of action of the resultant hydrostatic force on this wall from the free surfaces. Okay, so see here in this question, we have been provided with the rectangular wall which is having a width of 20 meter. So here it is having a width of 20 meter and it is having a height of 12 meter here. Okay, and it is holding a water up to a height of 7 meter. So here I can say the water is holding with this plate up with this level, that is 7 meter. So we have to calculate the correspondingly value of the line of action of the resultant hydrostatic force. So if you want to calculate the line of action of the resultant hydrostatic force, that means you have to calculate the value of the center of pressure, because the center of pressure is that point at which we assume that the hydrostatic force is acting. Okay, so here you can see, let us say the hydrostatic force is acting at this point. Okay, that point number P. So distance from this water free surface of the water up to this P point is known as the line of action of the resultant hydrostatic force. Okay, so here you can see this correspondingly value of H. In the case of rectangular wall, you can simply calculate by the 2/3 of the total depth. Okay, so if you solve this part, you will get the correct answer. That means the correct answer will come out to be around 4.67 here. Okay, you can also calculate this by using the expression, that is I upon a x bar plus x bar. Okay, you can also use this expression. That answer will provide, that procedure is a little bit lengthy, but it will provide you the same answer, don't worry. Okay, but just see here, if you want to calculate the distance from this surface, in that case I have to use this formula 2/3. Okay, आप ऐसे भी अज्यूम कर सकते हो, लेट अस सपोज कि अगर सिंपल सी प्लेट यहाँ पे होती, लेट अस से, ठीक है ना, और पानी का लेवल फ्री सरफेस काफी ऊपर है, तो इस केस में ये 2/3 नहीं होगा. उस केस में आपको प्रॉपर कैलकुलेशन परफॉर्म करनी पड़ेगी इस फॉर्मूले से, ध्यान रखना. ठीक है, तो इस केस में आपके पास ऑप्शन नंबर सी विल बी द करेक्ट आंसर. Okay, so let's move to our question number 84. Identify the correct statement related to the turbulent flow. Okay, so see here, turbulent flow के अंदर सरफेस को हाइड्रोडायनेमिकली स्मूथ कब हम बोलते हैं? किसी भी सरफेस को हाइड्रोलिकली स्मूथ या फिर हाइड्रोलिकली रफ डिफाइन करने के लिए हमें दो पैरामीटर्स चाहिए. सबसे पहले थिकनेस ऑफ द लैमिनार सब लेयर एंड द एवरेज सरफेस हाइट. ओके, एवरेज हाइट ऑफ द इरेगुलरिटीज. अब अगर हमारे पास यहाँ पे डेल्टा टी, दैट इज द थिकनेस ऑफ लैमिनार सब लेयर, इफ इज मोर देन द average height of the roughness, average height of the irregularity, in that case we say that the boundary is smooth. Okay, so here you can see the surface is considered hydrodynamically smooth if the sublayer thickness is much more than the average surface roughness. That means statement number 1 is correct here. And the velocity profile in turbulent flow is almost flat near the center. That is also correct. That means the option number C will be the correct answer of this case. Okay, that you have to understood. Okay, let's move to the last question of the test series. In an ideal vapor compression refrigeration cycle, the refrigeration effect is given to you as 125 kilojoule per kg, and the COP is given to you as 5, and the correspondingly flow of the refrigerant is given to you as 0.5 here. Okay, and we have to calculate the heat rejected in the condenser. So first of all, just see, the units of the refrigeration effect is given to you as kilojoule per kg, and we have to provide the answer in kilowatt here. Okay, so if you want to calculate the heat ejected in the condenser, so first of all you have to calculate how much work is done into work input is there in the compressor. Okay, so here I can say the correspondingly COP is given to you as refrigeration effect divided by work input. So here I can say the refrigeration effect is 125 divided by the COP is 5. Correspondingly, work input will be equal to 25 here. That is kilojoule per kg. Okay, that means the heat rejected in the condenser is equal to refrigerant refrigeration effect plus work input, that is 125 plus 25, that is 150 kilojoule per kg. Okay, so that's the value of the heat ejected in the condenser in kilojoule per kg. But we have to provide the value in kilowatt here. So in order to provide the value of the kilowatt in kilowatt, we have to multiply it with the mass flow rate, and the correspondingly answer will come out to be around as 75 kilowatt. So that means the option number D will be the correct answer of this case. Okay students, so यहाँ पे आपके पास कल आपका जो HPCL का एग्जाम है उसका फर्स्ट जो मॉक सीरीज था उसको हमने सॉल्व कर दिया, ठीक है। अब साथ में आपके पास यहाँ पे एक सेकंड जो टेस्ट हुआ HPCL का, उसको हम आपको यहाँ पे एज अ प्रैक्टिस पेपर आपको शेयर करेंगे, ठीक है ना। तो टेलीग्राम के ग्रुप में जो यहाँ पे YourPedia का है उसमें आपको यहाँ पे इसका सेकंड जो मॉक टेस्ट पेपर है फॉर प्रैक्टिस आपको मिल जाएगा सोल्यूशन के साथ। ओके, सो बेस्ट ऑफ लक फॉर योर प्रिपरेशन फॉर योर एग्जाम टुमारो। वंशी कृष्णा या डू सीबीटी मार्क। ओके, देखो आपके पास यहाँ पे इंटरव्यू के लिए सीबीटी मार्क जो है वो आपके पास यहाँ पे कंसिडर नहीं होंगे, ठीक है ना। इस केस में सिर्फ आपके पास क्या यहाँ पे जितना मुझे याद है इसमें आपके पास सिर्फ ये जो है क्वालिफाइंग है बस इस केस में, ठीक है। इसका थोड़ा सा ध्यान रखना। ओके, सो दैट्स इट फॉर टुडेज क्लास, फॉर टुडेज वीडियो। ओके, सो आपके पास जो प्रैक्टिस शीट हम आपको शेयर करेंगे सेकंड पेपर, तो उसको प्लीज एक बार ट्राई कर लेना कल एग्जाम देने से पहले। ओके, सो थैंक यू वेरी मच।